Beneath our feet, a secret waits. Silent, vast, forgotten. A hidden world carved from rock, stretching deep into darkness. Welcome to Derinkuyu, the ancient underground city buried beneath Turkey's Cappadocian plains. Descending 18 stories, it sheltered up to 20,000 people, complete with tunnels, churches, stables, and schools. Who built it? No one truly knows. But its labyrinthine halls echo with whispers of ancient fear, survival, and ingenuity. Discovered accidentally in 1963, Derinkuyu stunned archaeologists. Its complexity rivals modern engineering, leaving experts baffled. How did an ancient civilization, armed with only simple tools, create a marvel that challenges even today's architects? Derinkuyu's true purpose remains shrouded in mystery. Refuge? Fortress? Or perhaps something more enigmatic, waiting quietly beneath the earth, guarding secrets we have yet to uncover. Derinkuyu is an ancient underground city located in the Cappadocia region of Turkey. This remarkable subterranean complex was carved into the soft volcanic rock of the area, creating a vast network of tunnels, rooms, and passageways that extend deep beneath the Earth's surface. Dating back to around the 7th or 8th century BCE, Derinkuyu is believed to have been built by the Phrygians and later expanded by various civilizations, including the Byzantines. This underground marvel could accommodate up to 20,000 people, along with their livestock and food supplies, making it one of the largest and most complex underground settlements ever discovered. The city consists of multiple levels, reaching depths of up to 85 meters below the surface. It features an intricate system of ventilation shafts, water wells, living quarters, storage areas, and even religious spaces such as chapels. One of the most ingenious aspects of Derinkuyu is its security measures, including massive stone doors that could be rolled into place to seal off sections of the city in case of invasion. Derinkuyu served as a refuge for its inhabitants during times of conflict and persecution, allowing them to retreat underground and survive for extended periods. The discovery of this hidden city in 1963 has provided invaluable insights into ancient engineering and the resourcefulness of our ancestors in creating safe havens in challenging environments. Derinkuyu is situated in the Cappadocia region of central Turkey, specifically in the Nevşehir province. This ancient underground city lies beneath the modern town of Derinkuyu, about 50 kilometers south of Nevşehir city. The area is known for its unique geological features, particularly the soft volcanic rock that allowed for the construction of such an elaborate subterranean complex. The Cappadocia region, where Derinkuyu is found, is famous for its distinctive landscape of rock formations, often called fairy chimneys. These natural wonders eruptions millions of years ago, depositing layers of soft ash that hardened into tuff. Over time, wind and water erosion sculpted this malleable stone into the remarkable shapes we see today. This geological setting made it possible for ancient inhabitants to carve out the extensive network of underground chambers and tunnels that make up Derinkuyu. The city extends to a depth of approximately 60 meters below the surface, consisting of multiple levels connected by vertical staircases and narrow passages. The underground city of Derinkuyu was rediscovered in modern times in 1963. A local resident in the Cappadocia region of Turkey stumbled upon a hidden room behind a wall in his home. This chance discovery led to the unearthing of a vast subterranean network that had been lost to time for centuries. Excavations revealed a complex system of interconnected chambers, tunnels, and passageways extending deep into the earth. Archaeologists were astonished to find that Derinkuyu could accommodate thousands of people, complete with living quarters, storage areas, and communal spaces. While the exact date of Derinkuyu's original construction remains uncertain, experts believe it was first carved out of the soft volcanic rock as early as the 7th or 8th century BCE. The city continued to be expanded and used by various civilizations over the centuries, serving as a refuge during times of conflict or persecution. The rediscovery of Derinkuyu opened a window into the ingenuity and resilience of ancient societies. It sparked renewed interest in the hidden wonders that might still lie beneath our feet, waiting to be uncovered. Derinkuyu, the ancient underground city in Turkey, extends to remarkable depths beneath the surface. This vast subterranean network reaches approximately 250 feet into the earth, equivalent to the height of an 18-story building. The city consists of 8 distinct levels, each serving different purposes for its past inhabitants. As we descend through Derinkuyu, we encounter a complex system of rooms, passages, and chambers. The upper levels were primarily used for living quarters and daily activities, while the lower levels served more specialized functions. These deeper areas included storage rooms, wineries, and even religious spaces such as chapels. One of the most intriguing aspects of Derinkuyu is its sophisticated ventilation system. Despite being deep underground, the city maintained a constant flow of fresh air through a network of nearly 52 ventilation shafts. These shafts not only provided breathable air, but also helped regulate temperature throughout the underground complex. The lowest levels of Derinkuyu held particular importance. Here, we find a large cross-shaped church and what experts believe to be a missionary school, complete with study rooms. These deep chambers offered protection and secrecy, allowing inhabitants to practice their faith and educate their children away from potential threats above ground. Derinkuyu, the ancient underground city in Cappadocia, Turkey, is a marvel of ancient engineering and human ingenuity. This subterranean wonder extends deep beneath the surface, consisting of 11 distinct levels that reach depths of approximately 200 feet. Each level of Derinkuyu served a specific purpose in the daily lives of its inhabitants. The upper levels were primarily used for living quarters and storage, while the lower levels housed communal spaces, religious areas, and defensive structures. One of the most impressive features of Derinkuyu is its ventilation system, which runs throughout all 11 levels. This intricate network of air shafts ensured that even the deepest parts of the city received fresh air, making long-term habitation possible. The complexity and scale of Derinkuyu continue to astound archaeologists and visitors alike. Its multiple levels, interconnected by steep staircases and narrow passageways, could reportedly accommodate up to 20,000 people, providing shelter and protection during times of conflict or extreme weather. Derinkuyu, the ancient underground city in Turkey, is a marvel of ancient engineering and human ingenuity. This vast subterranean complex, carved into the soft volcanic rock of Cappadocia, is believed to have had the capacity to shelter between 18,000 and 20,000 people. The city descends to depths of approximately 200 feet below the surface, spanning 8 distinct levels. Each level served specific purposes, from living quarters and storage areas to communal spaces and places of worship. The intricate network of tunnels, rooms, and passageways allowed its inhabitants to live, work, and even raise livestock entirely underground for extended periods. Derinkuyu's sophisticated ventilation system, consisting of thousands of ventilation shafts, ensured a constant supply of fresh air throughout the complex. This, combined with numerous wells providing access to underground water sources, made long-term habitation possible. The city also featured ingenious security measures, including massive stone doors that could be rolled into place to seal off sections or entire levels in case of invasion. While the exact population of Derinkuyu at its peak remains uncertain, its vast size and complex infrastructure suggest it was designed to accommodate a significant number of people. This underground refuge served as a sanctuary during times of conflict or harsh weather conditions, showcasing the remarkable adaptability and resourcefulness of ancient civilizations. Derinkuyu stands out as a remarkable feat of ancient engineering and urban planning. Located in the Cappadocia region of Turkey, this underground city extends to a depth of approximately 250 feet, making it one of the deepest subterranean settlements ever discovered. What truly sets Derinkuyu apart is its vast scale and complexity. With the capacity to shelter up to 20,000 people along with their livestock and food supplies, the city features an intricate network of tunnels, rooms, and vertical staircases connecting its 8 distinct levels. Each level was meticulously designed to serve specific purposes, from living quarters and storage areas to communal spaces and places of worship. This sophisticated layout demonstrates an advanced understanding of urban design, even in such challenging underground conditions. One of the most ingenious aspects of Derinkuyu is its ventilation system. Despite being deep underground, the city maintained a constant supply of fresh air through a network of nearly 5,000 ventilation shafts. These shafts not only provided air, but also served as water conduits and possibly as a means of communication between levels. Security was paramount in the design of Derinkuyu. Massive stone doors, weighing up to 1,000 pounds, could be rolled into place to seal off sections of the city in case of invasion. This defensive feature, combined with its hidden nature, made Derinkuyu an ideal refuge during times of conflict, allowing its inhabitants to survive underground for extended periods, while remaining undetected by potential enemies above ground. Derinkuyu is considered an archaeological marvel due to its sheer scale and complexity as an ancient underground city. Located in the Cappadocia region of Turkey, this subterranean wonder stretches to depths of 200 feet below the surface and could accommodate up to 20,000 people. The city is a testament to the ingenuity of its builders, featuring an intricate network of tunnels, rooms, and passages spread across 18 levels. It includes living quarters, storage areas, communal spaces, and even wineries and oil presses. The ventilation system is particularly impressive, with thousands of ventilation shafts ensuring fresh air circulation throughout the complex. What truly sets Derinkuyu apart is its sophisticated security measures. Massive stone doors could be rolled into place to seal off each level, while hidden traps and confusing mazes were designed to thwart potential invaders. The city also boasted wells that were not connected to the surface, preventing contamination from outside sources. Archaeologists believe Derinkuyu was built in the 7th or 8th century BCE and was used for centuries as a refuge during times of war or religious persecution. Its discovery in 1963 opened a window into the lives and technological capabilities of ancient civilizations, making it a source of fascination for historians and tourists alike. Derinkuyu, an underground city in Turkey, stands as a testament to the ingenuity and resilience of ancient civilizations. This vast subterranean complex, carved into the soft volcanic rock of Cappadocia, extends to depths of over 200 feet and could accommodate thousands of people. The significance of Derinkuyu in archaeological studies lies in its unique design and purpose. Unlike many ancient structures built above ground, this city was created as a refuge from invaders and harsh weather conditions. Its elaborate network of tunnels, rooms, and ventilation shafts demonstrates advanced engineering skills that were far ahead of their time. Derinkuyu provides valuable insights into the social organization and daily life of its inhabitants. The city includes spaces for living, working, and worship, suggesting a well-planned community structure. Storage areas for food and water indicate long-term habitation capabilities, while the presence of wineries and oil presses points to a sophisticated economy. Furthermore, Derinkuyu challenges our understanding of ancient urban planning and defense strategies. Its hidden entrances, narrow passageways, and rolling stone doors reveal a complex security system designed to protect its residents. This underground marvel continues to fascinate researchers, offering a window into the advanced capabilities of our ancestors and prompting us to reconsider the achievements of ancient civilizations. Derinkuyu stands out among the underground cities of Cappadocia due to its sheer size and complexity. While there are numerous subterranean settlements in the region, Derinkuyu is the deepest, extending approximately 200 meters below the surface. This vast network of tunnels and chambers could reportedly accommodate up to 20,000 people along with their livestock and food stores. Unlike some of the smaller underground refuges in Cappadocia, Derinkuyu boasts a sophisticated ventilation system that allowed fresh air to circulate throughout its many levels. This engineering feat enabled inhabitants to live comfortably for extended periods, even when the city was sealed off from the outside world. Another distinguishing feature of Derinkuyu is its elaborate security measures. The city incorporates large stone doors that could be rolled into place to block access between different levels, providing an effective defense against invaders. This level of fortification is more extensive than in many other underground settlements in the region. Derinkuyu also stands out for its diverse functional spaces. The city includes areas dedicated to wine production, livestock keeping, and even religious practices, with chapels carved into the rock. This multifunctionality allowed for a more complete and sustainable underground society compared to some of the smaller, more basic shelters found elsewhere in Cappadocia. Derinkuyu, the remarkable underground city in Cappadocia, Turkey, was primarily constructed during the Byzantine era, around the 7th or 8th century. However, its origins likely stretch back much further, possibly to the Phrygian period in the 8th to 7th centuries BCE. The city was continually expanded and modified over centuries, with each successive civilization adding to its intricate network of tunnels, rooms, and passages. The most significant development and expansion of Derinkuyu occurred during the Byzantine period, when it served as a refuge for Christians fleeing persecution and Arab invasions. This era saw the creation of many of the city's most impressive features, including its complex ventilation system, water wells, and defensive mechanisms. Archaeologists believe that Derinkuyu could have housed up to 20,000 people, along with their livestock and food stores. The city extended to depths of up to 85 meters below the surface, featuring everything from living quarters and stables to churches, wineries, and storage rooms. The use of Derinkuyu continued well into the 20th century, with local residents using parts of the underground city for storage and shelter until the 1950s. Today, it stands as a testament to human ingenuity and the remarkable ability to adapt to challenging circumstances. The ancient underground city of Derinkuyu in Turkey has long fascinated archaeologists and historians. While the exact builders remain a subject of debate, many experts believe the Phrygians were responsible for its initial construction around the 7th or 8th century BCE. The Phrygians were an Indo-European people who migrated to Anatolia, now modern-day Turkey, and established a powerful kingdom in the region. However, the city's extensive network of tunnels and chambers was likely expanded and modified over centuries by various civilizations. The Hittites, who preceded the Phrygians in the area, may have begun the excavation process. Later, during the Byzantine era, Christians significantly enlarged and enhanced the underground complex, using it as a refuge from Arab invasions in the 7th and 8th centuries CE. Some scholars also suggest that the Cappadocian Greeks, who inhabited the region for centuries, played a crucial role in Derinkuyu's development. These local inhabitants likely continued to expand and maintain the underground city throughout its long history of use. It's important to note that Derinkuyu was not an isolated phenomenon. The Cappadocia region is home to numerous underground cities, suggesting a widespread practice of creating subterranean shelters. This underground network served as protection from invaders and extreme weather, showcasing the ingenuity and adaptability of ancient civilizations in this unique geological landscape. Derinkuyu, the ancient underground city in Cappadocia, Turkey, was primarily constructed as a refuge for its inhabitants during times of danger. This vast subterranean complex, carved into the soft volcanic rock, served as a secure haven where thousands of people could live for extended periods, safe from invaders and harsh environmental conditions. The city's intricate network of tunnels, rooms, and passageways spans several levels underground, reaching depths of up to 200 meters. This elaborate design allowed for the accommodation of up to 20,000 people, along with their livestock and food supplies. The primary purpose of such an extensive underground structure was to provide protection and shelter during periods of conflict or invasion. Derinkuyu's defensive features further highlight its purpose as a refuge. The city included heavy stone doors that could be rolled into place to seal off sections or entire levels, creating an impenetrable fortress against attackers. Ventilation shafts, crucial for sustaining life underground, were cleverly designed to be undetectable from the surface, ensuring the city's occupants could remain hidden for long periods. While serving as a sanctuary was its main function, Derinkuyu also incorporated spaces for daily life, including living quarters, storage areas, religious spaces, and even schools. This comprehensive design underscores the intention to create a fully functional underground society that could withstand prolonged periods of isolation, making it an extraordinary feat of ancient engineering and a testament to human ingenuity in the face of adversity. Derinkuyu, the remarkable underground city in Cappadocia, Turkey, has a long and fascinating history of human habitation. Archaeological evidence suggests that the first levels of this subterranean marvel were excavated as early as the 7th or 8th century before Common Era. The city continued to be expanded and inhabited for nearly 2 millennia, with its use extending well into the 20th century. During its long period of occupation, Derinkuyu served various purposes and housed different groups of people. It was initially created by the Phrygians, an ancient Indo-European people, and later expanded by early Christians seeking refuge from Roman persecution. The city reached its peak during the Byzantine era, when it could accommodate up to 20,000 people across its 8 to 11 underground levels. Derinkuyu remained an important sanctuary throughout the medieval period, providing protection for local inhabitants during times of war and invasion. Even after the region came under Ottoman rule in the 15th century, the underground city continued to be used, albeit less extensively. In the early 20th century, it served as a refuge for Greek Christians until around 1923. The city was eventually abandoned and forgotten until its rediscovery in 1963. This accidental finding occurred when a local resident stumbled upon a mysterious room behind a wall in his home, leading to the unveiling of this ancient underground metropolis. Today, Derinkuyu stands as a testament to human ingenuity and adaptability. Having sheltered and protected various civilizations for over 2,500 years, Derinkuyu, the ancient underground city in Cappadocia, Turkey, has a rich history of occupation by various civilizations. The Phrygians, an ancient Indo-European people, are believed to have initially carved out these subterranean chambers around 800 BCE. They created a vast network of rooms, tunnels, and ventilation shafts that would later be expanded by subsequent inhabitants. The Persians likely utilized the underground city during their rule over the region in the 6th and 5th centuries BCE. Following the Persians, the Greeks took control of Cappadocia after Alexander the Great's conquests. They too made use of Derinkuyu, possibly expanding its network and adding their own cultural touches to the existing structures. In the Byzantine era, from around 400 CE to 1100 CE, Derinkuyu saw significant development. Christian communities, seeking refuge from Arab invasions and religious persecution, further enlarged the underground city. They added churches, living quarters, and storage areas, creating a self-sufficient subterranean world that could house thousands of people. The last major occupants of Derinkuyu were likely Turkish Muslims, who continued to use and modify the underground city until it was abandoned in the early 20th century. Each civilization left its mark on this remarkable underground refuge, contributing to its complex and fascinating history that spans over 2 millennia. The political landscape of ancient Anatolia played a crucial role in shaping the construction of Derinkuyu, the remarkable underground city in Cappadocia, Turkey. During the tumultuous period between the 7th and 8th centuries, the region faced frequent invasions and conflicts, particularly from Arab forces expanding their territory. This constant threat of warfare and conquest created a pressing need for secure refuges. Derinkuyu, with its intricate network of subterranean chambers and passageways, was likely built as a response to these political and military pressures. The underground city could accommodate thousands of people, along with their livestock and supplies, providing a safe haven during times of attack. Its design included sophisticated defensive features such as heavy stone doors that could be sealed from the inside, ventilation shafts that doubled as communication channels, and wells that ensured a water supply even during long periods of isolation. The political instability of the region also influenced the layout and expansion of Derinkuyu over time. As different groups gained control of the area, they may have added to or modified the underground structure to suit their specific needs and defensive strategies. The complex nature of Derinkuyu suggests that its construction and development were ongoing processes, adapting to the changing political climate and evolving threats. The existence of Derinkuyu and other similar underground cities in Cappadocia reflects the ingenuity and determination of the local population in the face of persistent political turmoil. These hidden sanctuaries served not only as temporary shelters, but also as enduring symbols of resilience against the backdrop of ancient Anatolian power struggles. Derinkuyu, the ancient underground city in Cappadocia, Turkey, served as a crucial refuge during times of conflict in the region. This vast subterranean complex, carved deep into the soft volcanic rock, provided a safe haven for thousands of people and their livestock when danger threatened above ground. During periods of invasion or religious persecution, entire communities could disappear into Derinkuyu's labyrinthine network of tunnels and chambers. The city's ingenious design included multiple levels connected by narrow passageways, allowing defenders to seal off sections and trap invaders. Ventilation shafts brought fresh air to the lower levels, while water wells ensured a sustainable supply for long stays underground. Derinkuyu's strategic importance extended beyond mere shelter. It functioned as a hidden stronghold where resistance could be organized and supplies could be stored safely. The city's capacity to house large populations for extended periods made it an invaluable asset in times of siege or prolonged conflict. Perhaps most remarkably, Derinkuyu's role as a refuge spanned centuries. From ancient Hittite times through the Byzantine era and beyond, this underground marvel continued to offer protection to various groups facing threats. Its existence allowed local populations to weather waves of conquest and upheaval, preserving their cultures and ways of life in the face of overwhelming odds. The presence of the underground city significantly influenced the growth and structure of surface settlements in the region. As inhabitants moved between the subterranean and above-ground worlds, they developed unique architectural styles that blended elements from both environments. Buildings on the surface often incorporated hidden entrances and escape routes leading to the underground network, creating a seamless connection between the two realms. The underground city also served as a safe haven during times of conflict or harsh weather, allowing the surface settlements to persist and flourish even in challenging conditions. This resilience attracted more people to the area, leading to the expansion of both underground and above-ground communities. Trade and commerce thrived as the underground city provided storage space and protected marketplaces, supporting the economic growth of surface settlements. The complex tunnel systems facilitated the movement of goods and people, fostering a robust regional economy that extended far beyond the immediate area. Moreover, the underground city influenced social structures and governance in surface settlements. Leaders often held dual roles, managing affairs both above and below ground, which led to the development of unique political systems that considered the needs of both environments. This interconnectedness shaped the cultural identity of the region, creating a distinct society that valued adaptability, resourcefulness, and community cooperation. Derinkuyu, the ancient underground city in Turkey, reveals a fascinating history of multiple cultures through its archaeological remains. Excavations have uncovered artifacts and architectural features from various periods, indicating occupation by different groups over millennia. The earliest evidence suggests that the Hittites may have first carved out these subterranean chambers around 1800 BCE. Phrygian artifacts found in the deeper levels point to their presence in the first millennium BCE. As we move up through the layers, we find signs of Greek and Roman occupation, including distinct architectural styles and pottery. Perhaps the most extensive development of Derinkuyu occurred during the Byzantine period, from around 500 CE to 1000 CE. Christian symbols, churches, and expanded living quarters from this era are abundant. Later, during the Arab-Byzantine Wars, the city served as a refuge for Christians, leading to further expansion. Turkish Muslims also left their mark on Derinkuyu after the Seljuk conquest in the 11th century. Prayer rooms and Islamic artifacts provide evidence of their presence. This layering of cultural remains in Derinkuyu offers a unique vertical timeline of Cappadocia's rich history, showcasing the diverse civilizations that called this underground marvel home. The abandonment of Derinkuyu, the ancient underground city in Cappadocia, Turkey, remains shrouded in mystery. This vast subterranean complex, carved into soft volcanic rock, housed thousands of people across its many levels. However, the exact circumstances of its desertion continue to puzzle archaeologists and historians. Evidence suggests that Derinkuyu was occupied until the early 20th century. The city likely saw its last major use during the Turkish War of Independence in the 1920s, when it served as a refuge for Greek Christians fleeing persecution. After this period, the underground city fell into disuse and was largely forgotten. Several factors may have contributed to Derinkuyu's abandonment. The changing political landscape and population exchanges between Greece and Turkey in the 1920s led to the departure of many local inhabitants who knew about and maintained the underground city. Additionally, modernization and changes in warfare techniques made the underground refuge less necessary for protection. The rediscovery of Derinkuyu in 1963 occurred when a local resident found a mysterious room behind a wall in his home, leading to the exploration and excavation of the underground city. This chance discovery brought the forgotten marvel back into the spotlight, allowing us to study and appreciate this remarkable feat of ancient engineering and survival. Break time, 3.7s. Derinkuyu, the ancient underground city in Cappadocia, Turkey, was primarily carved out of soft volcanic rock. This rock, known as tuff, was formed from ash and debris ejected during volcanic eruptions millions of years ago. The malleable nature of tuff made it an ideal material for excavation and construction, allowing the ancient builders to create an extensive network of tunnels, rooms, and passageways. The builders of Derinkuyu used simple hand tools to carve out the underground spaces. These tools likely included chisels, hammers, and picks made of metal or stone. As they dug deeper into the earth, they left behind pillars of rock to support the ceilings and prevent collapse. These structural supports were crucial for maintaining the integrity of the underground city. In addition to the carved rock, the inhabitants of Derinkuyu used other materials to enhance the functionality of their subterranean dwelling. Stone doors, shaped like mill wheels, were used to seal off sections of the city for defense. These massive doors could be rolled into place from the inside, effectively blocking access to lower levels. The builders also incorporated ventilation shafts, extending from the surface to the deepest levels to ensure a steady supply of fresh air. Water management was a critical aspect of life in Derinkuyu. The builders created wells that tapped into underground water sources, providing a sustainable water supply for the inhabitants. These wells were strategically placed throughout the city, with some reaching depths of over 200 feet. The ingenuity displayed in the construction of Derinkuyu demonstrates the remarkable engineering skills of its ancient creators, who transformed volcanic rock into a livable underground metropolis. Ancient builders employed a variety of ingenious techniques to excavate vast underground structures. One common method was the use of fire setting, where intense heat was applied to rock faces, causing them to crack and become easier to remove. Workers would then use bronze or iron tools to chip away at the weakened stone. Another technique involved digging vertical shafts and horizontal tunnels. Teams of workers would start at multiple points, gradually connecting these passages to form larger chambers. This method allowed for efficient removal of excavated material and provided ventilation for those working below ground. Water was also a crucial tool in ancient excavations. In some cases, builders would direct water flows to erode softer rock layers, creating natural cavities that could be expanded. Additionally, water was used to soften certain types of rock, making them easier to carve and shape. The process of excavation was often a multi-generational effort, with work continuing for decades or even centuries. Ancient builders demonstrated remarkable planning and engineering skills, using simple tools and natural forces to create enduring underground marvels that continue to astound us today. The ancient underground city of Derinkuyu in Turkey was carved using simple yet effective tools. Stone chisels and hammers were likely the primary implements used to excavate the soft volcanic rock. These basic tools, made from harder stones or metals, allowed the ancient builders to chip away at the tuff, a type of rock formed from volcanic ash. Picks and shovels, crafted from wood and metal, would have been essential for removing debris and shaping larger sections of the underground structure. The builders might have employed wooden wedges, which could be inserted into cracks and then soaked with water to expand, helping split larger rocks. For precision work and creating intricate details, smaller hand tools such as awls and scrapers were probably used. These would have been crucial for carving out the complex ventilation shafts, water channels, and living spaces that make Derinkuyu so remarkable. Lighting was another crucial aspect of the construction process. Oil lamps and torches would have been necessary to illuminate the dark caverns as workers delved deeper into the earth, creating the extensive network of tunnels and rooms that extend over 18 levels below the surface. The ancient engineers who constructed the underground city employed several ingenious techniques to ensure its structural integrity. They carefully selected locations with stable rock formations, often choosing areas with volcanic tuff, a type of rock that is both soft enough to excavate and strong enough to support large structures. This material allowed them to carve out expansive chambers and intricate tunnel systems without compromising the overall stability of the underground complex. To further reinforce the structure, the builders left strategic support pillars throughout the excavated areas. These pillars, made from the same rock as the surrounding walls, distributed the weight of the overlying earth and prevented cave-ins. The designers also implemented a system of load-bearing arches in critical areas, which helped to disperse the pressure and maintain the integrity of larger chambers. Ventilation was another crucial factor in preserving the structural integrity of the underground city. The builders created an elaborate network of air shafts that not only provided fresh air to the inhabitants, but also helped regulate humidity levels. This ventilation system prevented the accumulation of moisture, which could have weakened the rock over time and led to structural issues. The ancient engineers also incorporated drainage systems to manage water infiltration. They carved sloping floors and channels to direct water away from living areas and vital storage spaces. This careful water management prevented erosion and maintained the stability of the underground environment, ensuring the longevity of this remarkable subterranean metropolis. Derinkuyu, an ancient underground city in Turkey, stands out for its remarkable architectural features that showcase human ingenuity and adaptability. This subterranean marvel extends to depths of approximately 200 meters, comprising a complex network of tunnels, rooms, and chambers carved into the soft volcanic rock. One of the most striking features of Derinkuyu is its elaborate ventilation system. A series of air shafts, over 50 of them, penetrate the entire depth of the city, ensuring fresh air circulation even in the deepest levels. This sophisticated system allowed thousands of people to inhabit the underground spaces for extended periods. The city also boasts an intricate water management system. Wells, not connected to the surface to prevent contamination, were dug deep into the earth to access the water table. These wells served the dual purpose of providing drinking water and regulating humidity in the underground environment. Perhaps the most unique feature of Derinkuyu is its security system. Massive stone doors, weighing up to 500 kilograms, could be rolled into place to seal off sections of the city. These doors were operated from the inside, allowing inhabitants to isolate themselves from potential threats. This defensive architecture, combined with the sheer scale and complexity of the underground network, makes Derinkuyu a testament to ancient engineering and urban planning. The ancient underground city of Derinkuyu in Turkey was an intricate network of interconnected spaces spanning multiple levels beneath the surface. These levels were ingeniously linked through a system of vertical shafts and sloping passageways, allowing inhabitants to move between different areas of the subterranean metropolis. The primary method of connection was a series of steep, narrow staircases carved directly into the soft volcanic rock. These staircases wound their way through the various floors, providing access to living quarters, storage rooms, and communal spaces. Some of these passageways were so narrow that people had to move in single file, which served as an effective defense mechanism against intruders. Large vertical shafts also played a crucial role in connecting the levels of Derinkuyu. These shafts served multiple purposes, functioning as ventilation systems to circulate air throughout the underground complex and as wells to access groundwater. Additionally, these shafts allowed for the efficient movement of goods and materials between levels using pulley systems. The city's designers also incorporated sloping corridors that gently descended from one level to the next. These gradual inclines made it easier to transport heavy items and allowed for the movement of livestock between the underground stables and the surface. The complex network of connections in Derinkuyu showcases the remarkable engineering and architectural skills of its ancient builders, creating a fully functional underground city that could sustain thousands of inhabitants. The narrow passageways in Derinkuyu, the ancient underground city in Turkey, served multiple crucial purposes in its intricate design. These tight corridors were carefully engineered to provide both security and efficient movement for the city's inhabitants. Primarily, these constricted passages acted as a formidable defense mechanism. Their narrow width made it extremely difficult for invaders to move through in large numbers or while fully armed. This design allowed defenders to easily control and repel any hostile forces attempting to infiltrate the subterranean refuge. Additionally, these passageways facilitated ventilation throughout the underground complex. The narrow design created a venturi effect, increasing air velocity and promoting circulation even in the deepest levels of the city. This ensured a constant supply of fresh air for the thousands of people who could potentially shelter within Derinkuyu during times of danger. Furthermore, the compact nature of these corridors maximized the available space in the underground city. By keeping pathways narrow, the designers could allocate more room for living quarters, storage areas, and communal spaces, effectively increasing the city's capacity and functionality. This efficient use of space was crucial in creating a sustainable underground environment capable of supporting a large population for extended periods. The ancient builders of the Great Pyramid demonstrated remarkable engineering skills in their design of ventilation shafts. These narrow passages, sometimes called air shafts, were ingeniously incorporated into the massive stone structure. Running from the inner chambers to the exterior, these shafts served multiple purposes beyond mere ventilation. The builders carved these shafts through the limestone blocks as they constructed the pyramid, aligning them precisely to connect the inner chambers with the outside world. Two shafts extend from the king's chamber, one pointing north and the other south, while two additional shafts originate from the queen's chamber. These passages measure approximately 20 centimeters by 20 centimeters in cross-section, barely large enough for a person to crawl through. Interestingly, the exact purpose of these shafts remains a subject of debate among Egyptologists and archaeologists. While ventilation was likely one function, some theories suggest they may have served as pathways for the pharaoh's spirit to ascend to the heavens. Others propose they could have been used for astronomical alignment, or as part of the construction process itself. Recent explorations using small robots have revealed previously unknown features within these shafts, including small doors with copper handles and mysterious markings. These discoveries continue to fuel speculation about the true purpose and sophistication of these ancient ventilation systems, reminding us that the Great Pyramid still holds many secrets waiting to be uncovered. The ancient Egyptians employed several ingenious techniques to waterproof the underground chambers of their tombs and temples. One primary method involved the use of limestone, a naturally water-resistant rock. The builders carefully selected and cut limestone blocks, fitting them tightly together to create a nearly impermeable barrier against groundwater seepage. To further enhance water resistance, the Egyptians applied a mixture of lime, mortar, and sand to seal the joints between stone blocks. This mortar not only bonded the stones together, but also filled any small gaps or cracks that might allow water to penetrate. In some cases, they added volcanic ash to the mortar, which reacted with the lime to create a substance similar to modern concrete, providing even greater water resistance. Another effective waterproofing technique was the application of bitumen, a naturally occurring, tar-like substance. The Egyptians used bitumen as a sealant, coating the exterior surfaces of underground chambers and the foundations of structures. This created a waterproof layer that helped protect the interior spaces from moisture infiltration. The ancient builders also incorporated drainage systems into their designs. They constructed sloped floors and channels to direct any water that did manage to enter away from important areas. These drainage systems worked in conjunction with the other waterproofing methods to keep the underground chambers dry and preserve their contents for millennia. The architects of the underground city faced unique challenges in planning for long-term sustainability. They focused on creating a self-sufficient ecosystem that could support human life for generations to come. One of their primary concerns was maintaining a stable atmosphere within the subterranean environment. To achieve this, they designed an advanced air filtration and circulation system that continuously purifies and recycles the air, removing carbon dioxide and other pollutants while replenishing oxygen levels. Water management was another crucial aspect of their sustainability plan. The architects implemented a closed-loop water recycling system that collects, treats, and redistributes water throughout the city. This system includes advanced purification technologies to ensure a constant supply of clean water for drinking, hygiene, and agriculture. Energy production and conservation were also key considerations. The underground city relies on a combination of geothermal energy, harnessing the Earth's natural heat, and nuclear fusion reactors to provide a stable and renewable power source. The entire city is designed with energy efficiency in mind, utilizing low-power lighting and appliances, as well as smart systems that optimize energy usage based on demand. Food production posed a significant challenge in the subterranean environment. The architects addressed this by incorporating vast hydroponic and aeroponic farms into the city's design. These high-tech agricultural systems use artificial lighting and carefully controlled nutrient delivery to grow a variety of crops without the need for soil or natural sunlight. This ensures a consistent food supply for the underground population while minimizing resource consumption. Break time, 3.7s. The ancient engineers of Derinkuyu, the remarkable underground city in Cappadocia, Turkey, devised an ingenious system to ensure proper air circulation throughout the vast subterranean complex. They created a network of ventilation shafts that extended from the deepest levels of the city all the way to the surface. These shafts, often disguised as wells, served a dual purpose of providing fresh air and regulating temperature within the underground chambers. The ventilation system relied on the principle of convection currents. As warm air naturally rises, it would exit through the upper shafts, creating a vacuum effect that drew cooler, fresh air down through other shafts. This continuous cycle ensured a constant flow of breathable air throughout the city, even in its deepest recesses. To further enhance air circulation, the engineers strategically placed these shafts at regular intervals throughout the city. They also incorporated narrow, angled passageways that helped to distribute air more effectively between different levels and chambers. This design not only provided ventilation, but also helped to control humidity levels, preventing the accumulation of dampness that could have led to health issues for the inhabitants. The sophistication of this ancient ventilation system is a testament to the advanced engineering knowledge of the civilization that built Derinkuyu. It allowed thousands of people to live comfortably underground for extended periods, showcasing the remarkable ingenuity of our ancestors in adapting to challenging environments. Derinkuyu, the ancient underground city in Cappadocia, Turkey, featured sophisticated water management systems that were crucial for sustaining life below the surface. The inhabitants engineered an intricate network of wells that tapped into underground water sources, ensuring a constant supply of fresh water. These wells were strategically placed throughout the subterranean levels, allowing access to water from various depths. The city also incorporated a series of vertical shafts that served multiple purposes in water management. These shafts facilitated ventilation, crucial for maintaining air quality in the underground chambers, while also acting as water conduits. During rainy seasons, these shafts collected and channeled surface water to lower levels, replenishing the underground reservoirs. Derinkuyu's designers implemented a clever filtration system to maintain water purity. As water moved through different levels of the city, it passed through layers of volcanic rock, which acted as a natural filter, removing impurities and ensuring the water remained potable. This system was particularly important given the limited access to external water sources during times of siege or conflict. The water management system in Derinkuyu also included storage areas and cisterns carved into the soft volcanic rock. These reservoirs could hold substantial amounts of water, allowing the underground population to survive extended periods without access to the surface. The careful planning and execution of these water systems demonstrate the advanced engineering capabilities of the ancient inhabitants of Derinkuyu. The ancient underground city of Derinkuyu in Turkey presented unique challenges for waste management. The inhabitants devised ingenious solutions to maintain sanitation in their subterranean dwellings. They created a network of small channels and pipes that ran throughout the city, allowing for the efficient removal of liquid waste. These channels were carefully sloped to use gravity, guiding waste away from living areas and towards designated disposal points. For solid waste, the people of Derinkuyu utilized a system of sealed storage areas. These were typically located in the lower levels of the city, far from living quarters and food storage. The waste was likely mixed with ash or other absorbent materials to reduce odors and manage decomposition. Periodically, this waste would be removed and used as fertilizer for crops grown on the surface. Ventilation shafts played a crucial role in waste management as well. These shafts, which provided fresh air to the underground city, also helped to dissipate odors and prevent the buildup of harmful gases from waste decomposition. The strategic placement of these shafts ensured a constant flow of air, maintaining a healthier environment within the city. The waste management systems of Derinkuyu demonstrate the advanced engineering and planning skills of its ancient inhabitants. Their solutions to this fundamental urban challenge allowed for long-term habitation of this extraordinary underground city, showcasing human ingenuity in adapting to unique living conditions. The underground city of Derinkuyu in Turkey, carved deep into the soft volcanic rock, presented unique challenges for illumination. Ancient inhabitants ingeniously used a combination of techniques to bring light to the subterranean chambers and passageways. Oil lamps were a primary source of light, fueled by olive oil or animal fat. These lamps, made of clay or metal, provided a steady, warm glow that could illuminate small areas. Strategically placed niches in the walls held these lamps, creating a network of light sources throughout the city. To maximize natural light, the builders incorporated light wells and ventilation shafts that extended to the surface. These vertical tunnels not only brought fresh air into the depths, but also allowed sunlight to penetrate the upper levels of the city. This clever design helped maintain a connection with the world above and provided a sense of time to those dwelling below. In areas where natural light could not reach, inhabitants relied on the flickering light of torches. These were often made from resinous wood or fabric soaked in pitch, providing a brighter, though shorter-lived, light source. The combination of these lighting methods allowed the underground city to function effectively, supporting a complex society hidden from the world above. Creating a stable temperature environment underground posed significant challenges for the engineers involved in the Large Hadron Collider project. They employed several innovative techniques to maintain consistent temperatures throughout the vast underground complex. One key strategy involved the use of advanced insulation materials lining the tunnel walls. These specially designed insulators helped minimize heat transfer between the surrounding rock and the interior spaces. Additionally, engineers implemented a sophisticated ventilation system that continuously circulates air throughout the facility, ensuring uniform temperature distribution. The cooling system itself is a marvel of engineering. It utilizes a network of pipes filled with liquid helium to cool the superconducting magnets to extremely low temperatures. This cryogenic system is carefully regulated to maintain precise temperature control, as even small fluctuations could affect the performance of the sensitive equipment. Furthermore, the engineers designed a heat recovery system that captures excess warmth generated by the equipment and redistributes it to other areas of the facility. This not only helps maintain temperature stability, but also improves overall energy efficiency. The combination of these methods allows the Large Hadron Collider to operate in a controlled environment, crucial for its groundbreaking experiments in particle physics. Ancient miners and engineers developed various techniques to prevent cave-ins and structural collapses in their underground excavations. One common method was the use of timber supports, where wooden beams and posts were strategically placed to reinforce tunnel walls and ceilings. These timber frames distributed the weight of the surrounding rock and soil, providing crucial stability to the excavated areas. Another effective technique was the creation of pillars. Miners would leave sections of unmined material as natural support columns throughout the excavation. These pillars acted as load-bearing structures, transferring the weight of the overlying rock to the floor and preventing collapse. The size and spacing of these pillars were carefully calculated based on the type of rock and the depth of the mine. In some cases, ancient engineers employed a method called cut and fill. This involved excavating a section of the mine, then backfilling it with waste rock and other materials to provide additional support. This technique not only prevented cave-ins, but also provided a stable working platform for further excavation. As mining and engineering knowledge advanced, more sophisticated methods were developed. The Romans, for example, introduced the use of arches and vaults in their underground constructions. These architectural elements distributed weight more effectively than flat ceilings, allowing for larger and more stable underground spaces. These ancient techniques laid the groundwork for modern mining and tunneling practices, demonstrating the ingenuity of early engineers in tackling the challenges of underground excavation. The ancient builders of Derinkuyu employed ingenious techniques to create and maintain the vertical shafts that were crucial to the underground city's functionality. These shafts served multiple purposes, acting as ventilation channels, water wells, and communication conduits between different levels. To create these shafts, the builders likely started from the surface and gradually worked their way down, carefully carving through the soft volcanic rock known as tuff. This material was ideal for excavation, being sturdy enough to support structures yet soft enough to be worked with primitive tools. The builders used a variety of hand tools, including chisels, picks, and hammers, to slowly and methodically carve out these vertical passages. Maintaining the structural integrity of these shafts was a constant challenge. The builders implemented a system of regular inspections and repairs to prevent collapse. They also designed the shafts with slight angles, rather than perfectly vertical alignments, which helped distribute the weight and pressure more evenly throughout the structure. One of the most impressive features of these shafts was their dual functionality as both ventilation systems and security measures. The builders created a network of thousands of small ventilation holes that connected to the main shafts, ensuring fresh air circulation throughout the underground city. These same shafts could be quickly sealed with large stone discs in times of danger, effectively turning the entire city into an impenetrable fortress. Ancient civilizations developed sophisticated drainage systems to manage water and prevent flooding. In the Indus Valley, cities like Mohenjo-Daro featured an intricate network of covered drains lining the streets. These drains were built with precisely laid bricks and sloped to allow water to flow efficiently. The system collected rainwater and wastewater from homes, directing it away from populated areas. The Romans took drainage engineering to new heights with their famous aqueducts and sewers. The Cloaca Maxima, one of the world's earliest sewage systems, served ancient Rome for centuries. This massive underground channel diverted water from low-lying areas and carried waste to the Tiber River, significantly reducing the risk of flooding and disease in the city. In medieval Europe, many cities adopted similar principles, constructing stone-lined channels beneath streets to carry away excess water. These systems often emptied into nearby rivers or seas, helping to keep urban areas dry during heavy rains. Some of these historic drainage networks continue to function today, testament to their ingenious design and durability. Modern cities have built upon these ancient concepts, implementing complex storm drain systems, retention ponds, and permeable surfaces to manage urban runoff and prevent flooding. These contemporary solutions combine time-tested principles with advanced materials and engineering techniques to protect our growing urban environments from water-related hazards. The engineers faced a significant challenge in ensuring the structural integrity of the upper levels of the International Space Station. They employed a combination of advanced materials and innovative design techniques to meet this crucial requirement. Lightweight yet incredibly strong aluminum alloys form the primary structure of the station's modules. These alloys provide excellent strength-to-weight ratios, essential for a structure that must withstand the rigors of space while minimizing launch costs. The engineers also incorporated carbon fiber composites in certain areas, further reducing weight without compromising strength. To counter the extreme temperature fluctuations in space, the station's exterior features multiple layers of insulation and protective materials. This thermal control system helps maintain a stable internal environment and prevents structural stress caused by expansion and contraction. Additionally, the modular design of the station allows for flexibility and easier assembly in orbit, with each component carefully designed to connect securely with others. The engineers also implemented a complex system of trusses and struts to distribute forces evenly across the structure. This framework helps the station withstand the stresses of docking procedures, crew movements, and orbital adjustments. Regular inspections and maintenance procedures ensure the continued integrity of these critical structural elements throughout the station's operational life. The underground city presented unique challenges for transporting materials, requiring ingenious solutions to overcome the constraints of subterranean spaces. One key innovation was the development of a network of pneumatic tubes that crisscrossed the city's levels. These tubes used compressed air to propel capsules containing small goods and documents swiftly through the urban labyrinth, enabling rapid delivery between distant points without clogging the narrow passageways with traditional vehicles. For heavier loads, engineers designed a system of magnetic levitation tracks that wound through the city's main arteries. These tracks supported specially designed cargo pods that could move silently and efficiently, even in tight turns and steep inclines that would be impossible for wheeled vehicles. The maglev system not only transported goods, but also doubled as a means of public transit, with passenger cars interspersed among the cargo pods. In the larger caverns and open spaces, a network of overhead cable cars and gondolas was implemented. These aerial transport lines could move both people and materials across vast underground chasms, utilizing the vertical space that was often left unused in traditional underground construction. This three-dimensional approach to city planning and transport maximized the use of available space while providing breathtaking views of the subterranean landscape. To complement these high-tech solutions, the city also incorporated more traditional methods adapted for underground use. Electric vehicles with low profiles and tight-turning radii were designed to navigate the smaller tunnels, while an extensive system of conveyor belts handled the continuous flow of resources between industrial sectors and residential areas. These diverse transport methods worked in concert to keep the underground city functioning smoothly, demonstrating the remarkable adaptability and creativity of its inhabitants. Break time. 3.7s. The ancient underground city of Derinkuyu in Turkey was a marvel of engineering and human adaptability. Carved deep into the soft volcanic rock of Cappadocia, this subterranean metropolis provided shelter for thousands of inhabitants, stretching to depths of approximately 200 meters. Life in Derinkuyu was organized vertically, with different levels serving distinct purposes. The upper levels were dedicated to living quarters where families resided in cave-like rooms. These spaces were connected by narrow passageways, allowing for easy movement while providing security against intruders. Lower levels housed communal areas, including storerooms for food, livestock pens, and wells for water access. The city even featured religious spaces, with churches and religious schools carved into the rock. Ventilation shafts running throughout the complex ensured a constant supply of fresh air, while a sophisticated system of heavy stone doors could seal off sections of the city for defense. The inhabitants of Derinkuyu lived in a state of constant readiness, able to retreat underground at a moment's notice. This underground refuge provided protection from invaders and harsh weather conditions, allowing its residents to survive and thrive in an otherwise challenging environment. The ingenuity and resilience displayed in Derinkuyu offer a fascinating glimpse into human adaptability and the lengths people will go to ensure their survival and security. Derinkuyu, the ancient underground city in Cappadocia, Turkey, was a marvel of engineering and design. This subterranean metropolis featured an intricate network of rooms and spaces carved into the soft volcanic rock, each serving a specific purpose for its inhabitants. The city included living quarters where families could reside, complete with bedrooms and common areas. These spaces were connected by narrow passageways, allowing for easy movement while maintaining security. Communal kitchens were strategically placed throughout the complex, equipped with ventilation shafts to expel smoke and bring in fresh air. Storage rooms were abundant in Derinkuyu, used for keeping food supplies and other essentials. The city also housed large meeting halls and places of worship, including churches adorned with religious symbols and frescoes. Educational spaces, possibly used as schools or for community gatherings, were also part of the layout. Perhaps most impressive were the city's defensive features. Massive stone doors could be rolled into place to seal off sections of the city, while ventilation shafts doubled as communication channels. Wells provided a reliable water source, crucial for long-term survival underground. This comprehensive design allowed thousands of people to live, work, and seek refuge in Derinkuyu for extended periods, showcasing the ingenuity of ancient civilizations in creating sustainable underground habitats. In the subterranean world of early human settlements, cooking and food preparation evolved to suit the unique challenges of underground living. Cave dwellers and those inhabiting rock shelters developed ingenious methods to prepare their meals in these dimly lit environments. Fire was a crucial element in underground cooking. Early humans would create small, controlled fires in well-ventilated areas of their caves or rock shelters. These fires served dual purposes, providing warmth and light, while also offering a means to cook food. Stone hearths were often constructed to contain the flames and provide a stable cooking surface. Various cooking techniques were employed underground. Roasting was a common method where meat or vegetables were placed on sticks or directly on hot stones near the fire. Boiling became possible with the invention of watertight containers, which could be made from animal skins or clay. These vessels were filled with water and heated using hot stones, allowing for the preparation of soups and stews. Food preservation was also practiced in these underground dwellings. Smoke from cooking fires would naturally permeate the cave atmosphere, inadvertently smoking and preserving meats hung from the ceiling. This technique not only extended the shelf life of food, but also added flavor. Additionally, the cool, stable temperatures of caves provided natural refrigeration, allowing inhabitants to store perishables for longer periods compared to above-ground storage methods. The sleeping arrangements in Derinkuyu, the ancient underground city in Turkey, were designed to accommodate thousands of people in a compact and efficient manner. The inhabitants carved out small, cave-like chambers from the soft volcanic rock, creating cozy sleeping quarters for families and individuals. These rooms were typically clustered together in residential areas, separate from communal spaces and storage rooms. The sleeping chambers were often simple in design, with smooth walls and low ceilings to conserve heat during cold nights. Some rooms featured small niches carved into the walls, which likely served as shelves for personal belongings or oil lamps. Larger family units might have occupied slightly more spacious chambers, while single individuals or smaller families shared more modest spaces. To maximize the use of limited space, many sleeping areas were equipped with stone platforms or ledges that served as beds. These raised surfaces would have been covered with straw, animal hides, or woven mats for comfort. In some cases, multiple levels of sleeping platforms were carved into the walls, creating a bunk bed-like arrangement to accommodate more people in a single room. The underground nature of Derinkuyu meant that ventilation and air circulation were crucial considerations. Clever engineering ensured that fresh air reached even the deepest levels of the city, including the sleeping quarters, through a complex network of air shafts and chimneys. This system not only provided breathable air but also helped regulate temperature, keeping the sleeping areas cool in summer and relatively warm in winter. Maintaining personal hygiene in underground environments presented unique challenges for residents. With limited water resources and confined spaces, innovative solutions were essential. Residents often relied on waterless cleaning methods, such as using antimicrobial wipes and dry shampoos to keep themselves clean. These products were specifically designed for low-water environments and helped control body odor and maintain skin health. For more thorough cleaning, residents used specially designed shower systems that recycled and purified water. These systems employed advanced filtration techniques to remove contaminants and conserve water, allowing for multiple uses before requiring replacement. Some underground facilities also utilized ultrasonic cleaning technology, which used high-frequency sound waves to remove dirt and oils from the skin without the need for large amounts of water. Oral hygiene was maintained through the use of waterless toothpastes and mouthwashes. These products were formulated to clean teeth and freshen breath without requiring rinsing. Residents also used disposable or washable clothing made from materials that naturally repelled odors and bacteria, reducing the need for frequent laundering. Waste management systems were crucial for maintaining overall hygiene in underground environments. Advanced composting toilets and waste processing units converted human waste into safe, odorless fertilizer, which could be used to support underground hydroponic gardens. These systems not only dealt with waste efficiently, but also contributed to the sustainability of the underground ecosystem. The underground community developed complex social structures to adapt to their unique environment. Living in subterranean spaces required careful organization and cooperation. Leaders emerged based on their ability to navigate the dark tunnels and manage limited resources. These individuals often held significant influence, guiding decisions about expansion, food distribution, and interactions with the surface world. Specialized roles became crucial for survival. Scouts were tasked with exploring new areas and identifying potential threats or resources. Engineers maintained the intricate systems of tunnels, ensuring structural integrity and proper ventilation. Farmers cultivated mushrooms and other fungi in carefully controlled environments, providing a stable food source for the community. Education took on a different form underground. Knowledge of the surface world was passed down through oral traditions, while practical skills for underground living were prioritized. The community placed high value on those who could remember and recount important information, as written records were often impractical in the damp, dark conditions. Social gatherings centered around communal areas where artificial light sources allowed for more interaction. These spaces became hubs for trading, storytelling, and decision-making, fostering a strong sense of unity among the underground dwellers. Despite the challenges of their environment, the underground community developed a rich culture uniquely adapted to their subterranean home. In the extensive subterranean world, inhabitants developed sophisticated methods of communication to overcome the challenges of their unique environment. Sound played a crucial role, with a system of rhythmic tapping on cave walls serving as a form of long-distance messaging. This method, reminiscent of Morse code, allowed information to travel quickly through the winding tunnels. Bioluminescent organisms were also harnessed for visual communication. Certain species of fungi and bacteria were cultivated in strategic locations, creating living signposts that could be activated or dimmed to convey different messages. This ingenious use of natural resources provided a silent yet effective way to transmit information across the darkness. For more complex communications, the underground dwellers utilized an intricate network of air currents. By manipulating these flows through a series of vents and chambers, they could send scent-based messages over vast distances. Each distinct aroma corresponded to a specific meaning, allowing for nuanced communication without the need for visual or auditory cues. As their civilization advanced, they developed a form of bioelectric communication. By tapping into the natural electrical fields generated by mineral deposits in the cave systems, they created a primitive yet effective version of a telegraph system. This allowed for rapid, long-distance communication that became vital for coordinating activities across their expansive underground realm. The ancient underground city of Derinkuyu in Turkey likely supported a diverse range of occupations essential for its unique subterranean society. Skilled stonemasons and engineers would have been crucial for carving out and maintaining the vast network of tunnels, rooms, and ventilation shafts. These experts ensured the structural integrity of the underground spaces and devised ingenious systems for air circulation and water management. Agriculture played a vital role in sustaining the population, with farmers cultivating crops on the surface and storing harvests in underground granaries. Livestock keepers tended to animals in specially designed underground stables. Water management specialists maintained wells and distribution systems, ensuring a steady supply of this precious resource throughout the city. Religious leaders and educators would have been present, as evidenced by the discovery of churches, schools, and meeting halls within the complex. Craftspeople such as potters, weavers, and metalworkers likely practiced their trades in dedicated workshops, producing essential goods for daily life. Merchants and traders facilitated the exchange of goods within the city and with outside communities. Security personnel were undoubtedly important, guarding entrances and operating the massive stone doors that could seal off sections of the city during times of danger. Additionally, administrators and civic leaders would have been necessary to organize and govern the underground community, ensuring its smooth operation and survival in this extraordinary subterranean environment. Life in the underground city presented unique challenges for children's play and learning. With limited space and resources, families and educators had to be creative in their approach. Children often engaged in games that required little equipment, such as hide and seek in the winding tunnels or storytelling circles that passed down the history and traditions of their subterranean community. Educational activities were integrated into daily life, with children learning practical skills like hydroponics for food cultivation and water conservation techniques. Makeshift classrooms were set up in larger caverns, where teachers used the rock walls as natural chalkboards. Interactive lessons on geology and engineering were commonplace, as understanding their environment was crucial for survival. Physical education took on new forms in the confined spaces. Children participated in low-impact exercises and stretching routines to maintain their health without the luxury of large playgrounds. Some areas were designated as soft play zones, with padding added to the rock surfaces to allow for safer physical activity. Technology played a significant role in both education and entertainment. Virtual reality systems were used to simulate outdoor environments, allowing children to experience activities like swimming or flying, which were impossible in their underground home. These virtual experiences also served as educational tools, teaching children about the world above and fostering dreams of one day returning to the surface. Religion was deeply woven into the fabric of daily life for the inhabitants of Derinkuyu, the ancient underground city in Cappadocia, Turkey. The subterranean complex, believed to have been occupied from around the 7th or 8th century BCE to the 20th century CE, contains numerous places of worship that highlight the spiritual significance in the community. Christianity played a crucial role in Derinkuyu, especially during the Byzantine period. The underground city features several churches, including a large room near the 3rd and 4th levels that likely served as a religious school. These sacred spaces were not merely for weekly gatherings, but were integral to the daily routines and social structure of the inhabitants. Religious practices in Derinkuyu were closely tied to survival and protection. The underground city itself may have been constructed as a refuge for early Christians fleeing persecution. This connection between faith and safety would have reinforced the importance of religious observance in daily life, with prayers and rituals potentially serving as both spiritual comfort and practical reminders of the need for vigilance. The layout of Derinkuyu also reflects the central role of religion. Religious spaces were often located near communal areas, suggesting that spiritual activities were seamlessly integrated with other aspects of daily life, such as food preparation, education, and social gatherings. This physical proximity of sacred and secular spaces underscores how religion permeated every aspect of life for the inhabitants of this remarkable underground city. Break time, 3.7s. The ancient underground city of Derinkuyu in Cappadocia, Turkey, was a marvel of defensive engineering. Its inhabitants employed several clever strategies to protect themselves from potential invaders. One of the most effective defensive features was the network of narrow, winding passageways connecting different levels of the city. These passages were designed to be easily blocked by large stone doors, which could be rolled into place from the inside. This allowed the inhabitants to seal off sections of the city quickly, trapping or confusing invaders who managed to enter. The city's ventilation system also served a dual purpose. While providing fresh air to the underground dwellers, it could be manipulated to cut off oxygen supply to specific areas, potentially suffocating intruders. Additionally, the inhabitants could use these shafts to pour hot oil or other substances onto attackers. Derinkuyu's multiple levels, extending up to 200 feet below ground, provided another layer of defense. If invaders breached the upper levels, the inhabitants could retreat deeper into the earth, using hidden trapdoors and secret passages to evade capture. This complex layout, combined with the inhabitants' intimate knowledge of their underground home, gave them a significant advantage over any would-be conquerors. Derinkuyu, the ancient underground city in Cappadocia, Turkey, was an engineering marvel with numerous security features designed to protect its inhabitants. The city's entrance was concealed by a large stone door that could only be opened from the inside, making it nearly impossible for outsiders to detect or breach. This massive circular stone, resembling a millstone, could be rolled into place to seal off access entirely. Within the subterranean network, narrow passageways connected different levels and chambers. These corridors were intentionally designed to be tight and low, forcing any intruders to bend down and move in single file. This layout made it easier for defenders to repel attacks and control movement through the city. Strategic choke points were also incorporated, allowing defenders to block entire sections quickly. The ventilation system of Derinkuyu served a dual purpose. While providing fresh air to the underground inhabitants, it was also designed with security in mind. The air shafts were too narrow for invaders to enter, and they could be quickly sealed if needed to prevent smoke or poison from being introduced into the city. Water management was crucial for long-term survival during sieges. Derinkuyu featured a sophisticated water well system that was only accessible from the inside. This ensured a secure water supply and prevented enemies from contaminating or cutting off this vital resource. The multiple levels of the city, extending up to 200 feet underground, provided additional layers of security, allowing inhabitants to retreat deeper if upper levels were compromised. The sustainability of an underground city during a siege would depend on several critical factors. Food supplies would be paramount, with carefully managed stockpiles and potentially some hydroponic farming systems to supplement rations. Water sources would be equally crucial, requiring secure access to underground aquifers or extensive storage facilities. Air quality and circulation would present significant challenges, necessitating advanced filtration systems and possibly air recycling technology. Energy production would be vital, likely relying on geothermal sources or nuclear power to maintain essential systems and life support. The psychological impact of prolonged confinement cannot be overlooked, as it could lead to social unrest or mental health issues among the population. Careful planning and robust governance structures would be necessary to manage resources and maintain order. Ultimately, a well-designed underground city with extensive preparations could potentially sustain its population for several years, but the exact duration would hinge on the initial resource stockpiles, the efficiency of recycling systems, and the size of the population relative to available space and supplies. Throughout history, humans have developed various ingenious methods to store food for long-term survival. One of the oldest and most widely used techniques is drying. By removing moisture from foods like fruits, meats, and grains, early societies could prevent spoilage and preserve nutrients for extended periods. This method was particularly effective in arid climates where the sun and wind naturally aided the drying process. Fermentation emerged as another crucial preservation technique. By harnessing the power of beneficial microorganisms, people could transform perishable foods into long-lasting products. Fermented foods like yogurt, cheese, and pickled vegetables not only lasted longer, but also provided additional nutritional benefits. Salt played a vital role in food preservation, especially for meats and fish. The process of salting drew out moisture and created an inhospitable environment for harmful bacteria. This method allowed coastal communities to store seafood for inland trade and helped inland populations preserve their livestock through harsh winters. In colder regions, people utilized the natural refrigeration provided by ice and snow. They would cut large blocks of ice from frozen lakes and rivers, storing them in insulated ice houses. This primitive form of refrigeration allowed communities to keep perishables fresh for months, bridging the gap between harvest seasons and ensuring a stable food supply year-round. The inhabitants faced significant challenges in maintaining air quality during their prolonged stays underground. To address this crucial issue, they developed sophisticated air filtration and circulation systems. These systems were designed to remove carbon dioxide, dust, and other contaminants while replenishing oxygen levels. One key component of their air management strategy involved the use of bioregenerative life support systems. These systems utilized carefully selected plants and algae to naturally convert carbon dioxide into oxygen through photosynthesis. The inhabitants cultivated these organisms in dedicated hydroponic chambers, which also served as a source of fresh food. Additionally, advanced chemical scrubbers were employed to remove harmful gases and particles from the air. These scrubbers used specialized materials to absorb contaminants, ensuring the air remained breathable. Regular maintenance and replacement of these filtration systems were critical to their continued effectiveness. The underground dwellers also implemented strict protocols for air conservation and recycling. This included carefully managing the use of resources that could impact air quality, such as limiting the use of combustion-based technologies and implementing efficient waste management systems to minimize the production of harmful gases. Living underground presented unique challenges for maintaining psychological health. Space agencies and researchers developed several strategies to support the mental well-being of individuals in these confined environments. One key approach was to create a sense of routine and normalcy. Daily schedules included regular work hours, leisure time, and sleep periods to mimic life on the surface. This structure helped individuals maintain a sense of purpose and stability despite the unusual surroundings. Environmental design played a crucial role as well. Living spaces incorporated lighting systems that simulated natural daylight cycles, helping to regulate circadian rhythms and mood. Virtual reality technology was used to provide immersive experiences of outdoor environments, allowing inhabitants to feel connected to nature and open spaces. Social interaction was carefully managed to prevent isolation and conflict. Group activities and team-building exercises were regularly scheduled, while private spaces were also provided for personal time. Communication with family and friends on the surface was facilitated through video calls and messaging systems, helping to maintain important social connections. The residents of Derinkuyu, an ancient underground city in Turkey, faced unique challenges when dealing with medical emergencies in their subterranean environment. While specific details about their medical practices are limited, archaeologists and historians have made educated guesses based on evidence found in the excavated city and knowledge of contemporary civilizations. One key aspect of handling medical emergencies underground was likely prevention. The inhabitants of Derinkuyu would have placed great importance on maintaining cleanliness and hygiene to prevent the spread of diseases in their enclosed living spaces. They had sophisticated ventilation systems and water management, which would have helped in this regard. When medical emergencies did occur, the community probably relied on traditional remedies and herbal medicines. Plants with medicinal properties could have been grown in small gardens near ventilation shafts, providing a source of natural treatments. For more severe cases, it is possible that designated areas within the underground complex served as rudimentary infirmaries where the sick or injured could be tended to away from the general population. In extreme situations, the inhabitants may have had no choice but to transport patients to the surface for treatment, especially if specialized care or specific resources were required. This would have been a risky endeavor, particularly during times of conflict when the underground city was used as a refuge. The community likely developed a system to weigh the risks of exposure against the severity of the medical emergency, making difficult decisions to ensure the survival of both individuals and the group as a whole. The underground city had several well-developed contingency plans for evacuation in case of emergencies. These plans were regularly updated and practiced to ensure all residents knew the procedures. The main evacuation routes led to large elevator shafts that could quickly transport thousands of people to the surface. As a backup, there were also spiraling emergency stairways built into the rock walls. In addition to these primary evacuation methods, the city planners had incorporated a network of escape tunnels that branched out in different directions. These tunnels were designed to provide alternative exit points in case the main routes became blocked or compromised. Each sector of the city was equipped with emergency supply caches containing food, water, and medical equipment to support evacuees during their journey to the surface. The city's advanced early warning system was a crucial component of the evacuation plans. It could detect a wide range of potential threats, from seismic activity to atmospheric changes, giving residents valuable time to prepare and move to safety. This system was integrated with a citywide communication network that could instantly relay instructions and updates to all inhabitants. Perhaps most impressively, the underground city featured a fleet of specialized evacuation vehicles. These rugged, high-capacity transports were designed to navigate both the underground tunnels and the harsh surface environment, ensuring that even those unable to walk could be safely evacuated. All these measures combined to create a comprehensive and robust evacuation strategy for the underground city. In the context of our cosmic exploration, we haven't encountered any enclosed spaces with inhabitants dealing with fire threats. Our journey through the universe has focused on celestial bodies, cosmic phenomena, and the vast expanses of space. Perhaps you're referring to a different topic or scenario. Let's redirect our attention to the wonders of the cosmos. What aspect of the universe would you like to explore? We could discuss the fiery hearts of stars, the scorching surfaces of certain planets, or the intense radiation found in various cosmic environments. In underground environments where natural light cycles are absent, humans have devised ingenious methods to track time. One common approach involves using mechanical clocks, such as pendulum clocks or spring-driven timepieces, which can operate independently of external cues. These devices allowed underground dwellers to maintain a sense of day and night, crucial for preserving normal sleep patterns and work schedules. Another method employed in underground timekeeping was the use of water clocks, also known as clepsydras. These ancient devices measure time by regulating the flow of water from one container to another. The consistent dripping of water provided a reliable means of tracking hours, even in the absence of sunlight. For longer time periods, underground inhabitants often relied on calendars and manual record-keeping. By meticulously noting the passage of days, weeks, and months, they could maintain alignment with the above-ground world. Some underground facilities even installed complex lighting systems that mimicked the natural cycle of daylight, helping residents maintain their circadian rhythms. In more modern underground settings, such as scientific research stations or military bunkers, atomic clocks and radio-synchronized timepieces have become the gold standard. These highly accurate devices can maintain precise time for extended periods, ensuring that underground operations remain perfectly synchronized with the outside world. Break time, 3.7s. The inhabitants of Derinkuyu, an ancient underground city in Turkey, faced unique challenges in food cultivation due to their subterranean lifestyle. Despite living primarily below ground, they developed ingenious methods to sustain themselves. One key approach was the use of vertical ventilation shafts that extended from the surface to the deepest levels of the city. These shafts served a dual purpose. They provided fresh air to the inhabitants and allowed some sunlight to penetrate the upper levels. In these partially illuminated areas, the people of Derinkuyu grew crops that could tolerate low light conditions, such as certain types of fungi and sprouts. For more substantial agricultural needs, the inhabitants relied heavily on surface-level farming. They would emerge from hidden entrances to tend to fields and orchards above ground during peaceful times. These crops were then harvested and stored in the cool, dry conditions of the underground city, which acted as a natural preservation system. Additionally, the people of Derinkuyu kept livestock in designated areas of the underground complex. Animals such as chickens and goats provided a steady supply of eggs, milk, and meat. The waste from these animals was likely used as fertilizer for their limited underground cultivation efforts, creating a sustainable cycle of food production in this remarkable subterranean world. In the underground city of Derinkuyu, located in the Cappadocia region of Turkey, the ancient inhabitants cultivated a variety of crops adapted to the unique subterranean environment. These resourceful people primarily grew mushrooms, which thrive in dark, humid conditions. The constant temperature and moisture levels in the underground chambers provided ideal conditions for mushroom cultivation, allowing the residents to maintain a steady food supply. Additionally, the people of Derinkuyu utilized hydroponic techniques to grow certain vegetables and herbs. They created small gardens in areas where limited sunlight could penetrate through ventilation shafts. Crops such as lettuce, spinach, and various herbs were grown using nutrient-rich water solutions, maximizing the use of available space and resources. The underground farmers also developed methods to cultivate root vegetables like potatoes and turnips in specially designed chambers with nutrient-rich soil. These crops required minimal light and could be stored for extended periods, making them valuable food sources during times of conflict or harsh surface conditions. While the variety of crops grown underground was limited compared to surface agriculture, the ingenuity of the Derinkuyu inhabitants allowed them to maintain a diverse and nutritious diet even in their subterranean home. This agricultural adaptability played a crucial role in sustaining life in this remarkable underground city for extended periods. Managing livestock in subterranean environments presented unique challenges and required innovative solutions. Underground farmers had to adapt traditional agricultural practices to suit the constraints of limited space and absence of natural light. They developed specialized breeding programs to create smaller, more compact livestock varieties that could thrive in confined spaces. Artificial lighting systems were crucial for maintaining the health of animals and promoting proper growth. These systems mimicked natural day-night cycles, ensuring the livestock received adequate rest and maintained normal biological rhythms. Farmers also implemented advanced ventilation systems to regulate air quality and temperature, preventing the buildup of harmful gases and maintaining a comfortable environment for the animals. Nutrition posed another significant challenge. With no access to grazing land, farmers relied on hydroponically grown feed and carefully formulated supplements to meet the dietary needs of their livestock. They also developed efficient waste management systems, often incorporating biogas digesters to convert animal waste into energy, thus creating a more sustainable and self-sufficient underground ecosystem. Health management was particularly critical in these enclosed environments. Strict biosecurity measures were implemented to prevent the spread of diseases, and regular health checks became standard practice. Some underground facilities even developed automated monitoring systems to track the well-being of individual animals, allowing for early detection and treatment of potential health issues. Underground agriculture has seen remarkable advancements in recent years, driven by the need for sustainable food production in urban environments and harsh climates. One of the most notable innovations is the development of hydroponic systems specifically designed for subterranean use. These systems utilize nutrient-rich water solutions to grow crops without soil, maximizing space efficiency and water conservation in underground settings. Vertical farming techniques have been adapted for underground spaces, allowing for multiple layers of crops to be grown in a single area. This approach significantly increases yield per square meter and makes efficient use of limited underground real estate. LED lighting technology has also played a crucial role, with specially designed grow lights that mimic natural sunlight and can be fine-tuned to optimize plant growth cycles. Climate control systems have been refined to maintain ideal temperature, humidity, and carbon dioxide levels in underground farms. These systems often incorporate geothermal energy for heating and cooling, further enhancing sustainability. Additionally, automated monitoring and management systems have been developed to track plant health, nutrient levels, and environmental conditions, allowing for precise control and reduced human intervention. Innovative pest management strategies have also emerged for underground agriculture. These include the use of beneficial insects, ultraviolet light traps, and even sound waves to control pests without relying on chemical pesticides. Such techniques ensure the production of clean, healthy crops while maintaining the delicate ecosystem balance of underground farming environments. Maintaining a balanced diet for the underground population presented significant challenges, but scientists and nutritionists developed innovative solutions. Hydroponic farming became a cornerstone of food production, allowing for the cultivation of a variety of fruits and vegetables in controlled environments. These systems used nutrient-rich water solutions instead of soil, maximizing space efficiency and crop yields. Protein sources were diversified to include both plant and animal options. Insect farming, particularly crickets and mealworms, provided a sustainable and space-efficient protein source. These insects required minimal resources and could be processed into protein-rich flour or consumed whole. Fish farming in carefully managed aquaponic systems also contributed to the protein supply while simultaneously supporting vegetable growth. Vitamin D, normally obtained through sunlight exposure, was supplemented through fortified foods and specialized lamps that mimicked natural sunlight. Algae cultivation became crucial for producing omega-3 fatty acids and other essential nutrients. Mushroom farming in dark, climate-controlled rooms provided additional nutrients and helped diversify the diet. Careful meal planning and portion control ensured that every individual received the necessary nutrients. Regular health checkups and blood tests allowed nutritionists to adjust dietary plans as needed, addressing any deficiencies promptly. This comprehensive approach to nutrition helped maintain the health and well-being of the underground population despite the challenging circumstances. Ancient civilizations developed ingenious methods to store and preserve their hard-earned harvests. One common technique was the use of underground storage pits. These pits, often lined with straw or clay, provided a cool, dry environment that helped prevent spoilage and protect grains from pests. In drier climates, people built elevated granaries. These structures allowed air to circulate beneath the stored crops, reducing moisture and deterring rodents. Some cultures, like the ancient Egyptians, constructed massive stone silos capable of holding thousands of bushels of grain for years. Preservation techniques varied depending on the crop. Drying was a widespread method used for fruits, vegetables, and herbs. Sun-drying or smoking not only extended the shelf life of foods but also concentrated flavors. Fermentation was another crucial preservation technique, transforming perishable foods into long-lasting products like wine, pickles, and cheese. Salt played a vital role in food preservation, particularly for meats and fish. Salting drew out moisture, creating an inhospitable environment for bacteria. This method allowed seafaring cultures to store provisions for long voyages and inland communities to enjoy ocean bounty far from the coast. In the underground agricultural areas, managing pests and diseases presented unique challenges that required innovative solutions. The enclosed environment of these subterranean farms actually offered some advantages in pest control, as it was easier to prevent outside insects and pathogens from entering the growing areas. One key strategy involved strict biosecurity measures. All materials, including seeds, soil, and equipment, were thoroughly sterilized before being brought into the underground spaces. Workers followed rigorous decontamination procedures to avoid introducing harmful organisms. Biological pest control methods were favored over chemical pesticides, which could accumulate in the closed system. Beneficial insects like ladybugs and predatory mites were introduced to control harmful pests. Additionally, certain plants known for their pest-repelling properties were strategically placed throughout the growing areas. For disease management, advanced air filtration systems were employed to remove spores and other airborne pathogens. Hydroponic and aeroponic systems were widely used, reducing the risk of soil-borne diseases. Regular monitoring and early detection systems allowed for swift isolation and treatment of any affected plants, preventing the spread of diseases in these confined agricultural spaces. Hydroponics did not play a role in food production at Derinkuyu. This ancient underground city, located in the Cappadocia region of modern-day Turkey, relied on more traditional agricultural methods for sustenance. Derinkuyu, carved into soft volcanic rock, was an impressive subterranean settlement that could house thousands of people. Its inhabitants primarily cultivated crops on the surface, using the fertile volcanic soil of the region. They grew grains, fruits, and vegetables in fields above ground during times of peace. The underground city featured storage rooms where harvested crops and other food supplies could be kept for extended periods. These storage areas were crucial for survival during times when the population had to retreat underground for safety, such as during invasions or periods of conflict. While Derinkuyu did not use hydroponics, it did have sophisticated water management systems. The city accessed groundwater through deep wells, which provided a reliable water source for drinking and basic needs. This water system was essential for sustaining life in the underground city, but was not used for hydroponic farming. In environments where natural pollinators were scarce or absent, early space colonists had to develop innovative methods to ensure plant reproduction. One primary technique involved manual pollination, where botanists and agricultural specialists would carefully transfer pollen from one plant to another using small brushes or cotton swabs. This meticulous process mimicked the role of bees and other insects, allowing crops to produce fruits and seeds. Another approach utilized automated systems equipped with tiny robotic arms and sensors. These machines could detect when plants were ready for pollination and delicately transfer pollen between flowers. Some colonies experimented with creating controlled air currents within their greenhouses, simulating the effect of wind pollination for certain plant species. In more advanced setups, scientists developed specialized pollinator drones. These miniature flying robots were programmed to move from flower to flower, collecting and distributing pollen, much like their biological counterparts. The drones were equipped with cameras and sensors to identify flowers at the right stage of maturity and ensure efficient pollination. Research also focused on genetically modifying plants to enhance self-pollination capabilities or to produce viable seeds without the need for pollination. While these methods were not suitable for all crop types, they provided valuable alternatives in the challenging conditions of space colonies, ensuring a stable food supply for the inhabitants. Underground farming significantly improved the nutritional health of the inhabitants living in subterranean environments. These innovative agricultural techniques allowed for the cultivation of a diverse range of crops, providing essential vitamins and minerals that were previously scarce in their diets. The controlled environment of underground farms enabled year-round production, ensuring a consistent supply of fresh fruits and vegetables. This steady availability of nutrient-rich foods helped combat deficiencies and boost overall immune function among the population. Hydroponic and aeroponic systems, commonly used in these settings, allowed for efficient use of limited space and resources while producing high yields of leafy greens, herbs, and even some fruit-bearing plants. Furthermore, the integration of artificial lighting systems mimicking natural sunlight cycles promoted optimal plant growth and increased the nutritional content of the crops. This was particularly crucial for synthesizing vitamins that typically require sunlight, such as vitamin D. The ability to fine-tune growing conditions also led to the development of crops with enhanced nutritional profiles, tailored to address specific dietary needs of the underground inhabitants. The success of underground farming not only improved physical health, but also had positive effects on mental well-being. Access to fresh, homegrown produce fostered a sense of self-sufficiency and connection to nature, even in the most artificial of environments. This holistic approach to nutrition and well-being played a vital role in sustaining long-term underground habitation. Break time 3.7s. Derinkuyu, the ancient underground city in Cappadocia, Turkey, relied on an ingenious system of water management to sustain its inhabitants. The primary water source for this subterranean marvel was a network of wells that tapped into the natural water table beneath the surface. These wells were strategically placed throughout the underground complex, reaching depths of up to 200 feet. The geological composition of the region played a crucial role in Derinkuyu's water supply. The porous volcanic rock that makes up the landscape allowed rainwater and melted snow to percolate through the layers, creating a rich underground aquifer. This natural filtration system provided the city with a steady supply of clean, fresh water. To complement the well system, the inhabitants of Derinkuyu also utilized an extensive network of water channels and cisterns. These structures were carefully carved into the soft rock, allowing for the efficient distribution and storage of water throughout the underground city. This comprehensive water management system ensured that even during times of siege or extended periods underground, the inhabitants had access to this vital resource. The ingenuity of Derinkuyu's water system extended beyond mere survival. The inhabitants also implemented ventilation shafts that served a dual purpose, bringing in fresh air and allowing excess moisture to escape, thus preventing the buildup of humidity in the underground chambers. This sophisticated approach to water and air management showcases the advanced engineering skills of the ancient people who called this underground city home. The inhabitants of the underground city devised ingenious methods to access and maintain a steady supply of fresh water. They tapped into natural underground aquifers, creating an intricate network of wells that reached deep into the earth. These wells were strategically placed throughout the city to ensure widespread access. To supplement their water supply, the city dwellers also developed sophisticated rainwater harvesting systems. Large catchment areas on the surface funneled rainwater into storage chambers below ground. This water was then filtered through layers of sand and gravel to remove impurities before being distributed throughout the city. The underground dwellers also mastered the art of water conservation. They implemented a system of channels and aqueducts to transport water efficiently, minimizing waste. Recycling greywater for non-potable uses, such as irrigation of underground gardens, further stretched their water resources. Perhaps most impressively, the inhabitants created a network of condensation traps in the cooler parts of their cave system. These traps collected moisture from the air, providing an additional source of fresh water even during dry periods. This multifaceted approach ensured a reliable water supply, allowing the underground city to thrive for generations. Ancient civilizations developed various ingenious methods to purify and maintain water quality. One common technique was the use of copper vessels to store water. The ancient Egyptians discovered that copper has antimicrobial properties which helped keep water clean and safe for drinking. This method is still used in some parts of the world today. Another widespread practice was the use of natural filtration systems. People would create layers of sand and gravel in large containers, allowing water to slowly percolate through these materials. This process effectively removed many impurities and particulates from the water. The Greeks and Romans further refined this technique by developing elaborate aqueduct systems that incorporated settling basins and filters. In India and other parts of Asia, people used the seeds of the Moringa oleifera tree to purify water. These seeds contain proteins that act as natural coagulants, causing impurities to clump together and settle at the bottom of the container. This method is remarkably effective and is still used in some regions where modern water treatment facilities are not available. Boiling water was also a common purification method across many cultures. People understood that heating water could make it safer to drink, even if they did not fully comprehend the concept of microorganisms. This simple yet effective technique remains one of the most reliable ways to ensure water safety in emergency situations or when traveling to areas with questionable water quality. In ancient civilizations, people developed various methods to prevent contamination of water sources. One common approach was to separate drinking water from wastewater. Many societies built complex systems of aqueducts and pipes to transport clean water from distant springs or rivers into their cities. These structures were often covered or underground to protect the water from external contaminants. Some cultures, like the ancient Romans, used lead pipes to distribute water, which ironically caused its own form of contamination. However, they also implemented settling tanks where water could sit, allowing sediment and impurities to sink to the bottom before the cleaner water on top was used. In other regions, people used natural filtration methods. They would dig wells near rivers, allowing the soil to naturally filter the water as it seeped through the ground. This method helped remove larger particles and some microorganisms. Additionally, many societies recognized the importance of keeping livestock and human waste away from water sources, establishing designated areas for these activities far from their drinking water supplies. While these methods were not perfect by modern standards, they demonstrate early understanding of the importance of clean water and the need to protect it from contamination. These practices laid the groundwork for the more advanced water treatment and distribution systems we use today. Throughout history, humans have devised various ingenious methods to store water, a vital resource for survival and civilization. Ancient civilizations often relied on large-scale reservoirs and cisterns to collect and store rainwater or river overflow. These structures were typically built using stone or brick and lined with waterproof materials like clay or lime plaster to prevent seepage. In arid regions, underground cisterns were common, protecting the precious water from evaporation and contamination. These subterranean chambers could be vast, capable of holding thousands of gallons of water. The ancient city of Constantinople, for instance, boasted hundreds of underground cisterns, with the largest, the Basilica cistern, able to hold millions of gallons of water. In more recent times, water towers became a prominent feature of many towns and cities. These elevated structures use gravity to create water pressure, ensuring a consistent supply to homes and businesses. Modern water storage systems have evolved to include large-scale reservoirs created by damming rivers, as well as sophisticated treatment and distribution networks that can serve millions of people. Today, as water scarcity becomes an increasing concern in many parts of the world, new technologies are being developed for water storage and conservation. These include advanced rainwater harvesting systems, aquifer storage and recovery methods, and even large-scale desalination plants in coastal areas. The quest for efficient water storage continues to be a crucial aspect of human civilization, adapting to our changing needs and environmental challenges. In ancient cities, distributing water throughout various levels was a complex engineering challenge. The Romans, masters of hydraulic engineering, developed sophisticated systems to move water across their vast empire. They constructed massive aqueducts that transported water from distant sources to urban centers, using gravity to maintain a consistent flow. Once the water reached the city, it was distributed through a network of lead pipes. These pipes, known as fistulae, branched out from large main lines to smaller pipes that served individual buildings and public fountains. The Romans used the principle of water pressure to their advantage, creating storage tanks at high points in the city to ensure water could reach upper floors of buildings. For taller structures, such as insulae or apartment buildings, additional measures were necessary. Water carriers, known as aquarii, would manually transport water to upper levels. Some wealthy homeowners installed their own water-lifting devices, such as bucket chains or water wheels, to bring water to higher floors. In more recent history, the invention of pumps and the understanding of fluid dynamics revolutionized water distribution. Modern cities use electric pumps to move water upwards, overcoming the limitations of gravity-fed systems and allowing for the construction of towering skyscrapers with reliable water supply at all levels. Protecting underground structures from flooding was a critical concern for ancient builders. They employed several ingenious techniques to keep water at bay. One common method was the use of waterproof materials like bitumen, a naturally occurring form of petroleum, to coat walls and floors. This created a barrier that prevented water from seeping through. Another effective strategy involved the construction of complex drainage systems. These networks of channels and pipes diverted water away from important areas, guiding it to safe collection points or out of the structure entirely. In some cases, ancient engineers even created sloped floors that naturally directed water towards these drainage outlets. Some cultures took flood prevention a step further by incorporating raised platforms or elevated foundations into their designs. This approach lifted the main living or storage areas above potential flood levels, providing an extra layer of protection against rising waters. Interestingly, some underground structures were designed to work with water rather than against it. For instance, certain ancient cisterns were built to collect and store rainwater, turning what could have been a destructive force into a valuable resource for times of drought. These multifaceted approaches to water management showcase the ingenuity of ancient builders in their quest to create lasting underground spaces. Managing wastewater in subterranean environments presented unique challenges for early underground dwellers. These resourceful inhabitants developed ingenious systems to handle waste and maintain sanitary conditions in their confined spaces. One common method involved the use of natural drainage systems. Cave dwellers often took advantage of existing water flows within the cave structure, channeling wastewater into underground streams or rivers that would carry it away from living areas. This natural flushing system helped prevent the buildup of harmful bacteria and unpleasant odors. In areas without natural water flows, people created artificial drainage systems. They dug channels and constructed primitive pipes to direct wastewater away from living quarters. These systems often led to designated areas far from the main living spaces, where waste could decompose naturally without affecting the inhabitants. Some underground communities used absorption pits, digging deep holes filled with gravel and sand to filter wastewater. This method allowed liquid waste to seep into the surrounding soil while trapping solid waste for later removal. In more advanced subterranean settlements, inhabitants even developed early forms of composting toilets, using organic materials to break down waste and reduce odors. Water was a crucial element in the daily life of Derinkuyu's inhabitants, playing a vital role in their survival and customs within the underground city. The ancient engineers who designed this subterranean marvel created an intricate network of wells and water channels that reached depths of over 200 feet. These systems not only provided essential drinking water, but also served various other purposes in the community's daily rituals. The inhabitants of Derinkuyu used water for cooking, cleaning, and maintaining personal hygiene. Large stone troughs were strategically placed throughout the underground complex, allowing residents to collect and store water for their daily needs. These communal water points likely served as gathering places where people would interact and share news while performing their daily tasks. Water also played a significant role in the agricultural practices of Derinkuyu. The underground city featured numerous ventilation shafts that doubled as water conduits, allowing the inhabitants to irrigate crops on the surface above. This ingenious system enabled the community to maintain a sustainable food supply even during prolonged periods underground. In addition to practical uses, water held spiritual significance for the inhabitants of Derinkuyu. Archaeological evidence suggests the presence of baptismal fonts and ritual bathing areas within the underground complex. These spaces indicate that water was an integral part of religious ceremonies and purification rituals, reflecting the deep connection between spiritual practices and this life-giving resource in the unique environment of Derinkuyu. Water management systems have undergone a remarkable transformation throughout human history. In ancient times, civilizations like the Indus Valley and Mesopotamia developed sophisticated irrigation networks to control flooding and distribute water for agriculture. These early systems laid the groundwork for more advanced techniques that would follow. As societies grew more complex, so did their water management strategies. The Romans, for example, constructed extensive aqueducts to transport water over long distances, supplying their cities with fresh water and supporting public baths. This engineering feat demonstrated a significant leap in water distribution technology. During the Industrial Revolution, water management took on new dimensions. The need for clean water in growing urban centers led to the development of modern water treatment plants and sewage systems. These innovations drastically improved public health and sanitation in cities around the world. In recent decades, water management has evolved to address environmental concerns and resource scarcity. Advanced technologies like desalination plants, water recycling systems, and smart metering have emerged to conserve and maximize water usage. Additionally, there is a growing emphasis on sustainable practices and ecosystem preservation in water management strategies, reflecting our evolving understanding of water's crucial role in both human societies and natural environments. Break time 3.7s. Archaeologists have uncovered several intriguing pieces of evidence suggesting religious practices in the ancient underground city of Derinkuyu. Located in the Cappadocia region of Turkey, this subterranean marvel has revealed rooms that appear to have been used for religious purposes. One of the most significant finds is a large room believed to be a religious school, complete with a barrel-vaulted ceiling and stone benches lining the walls. Researchers have also identified what they believe to be a missionary's room, indicating the presence of organized religious activities. This room features a unique stone carving on one wall, which some experts interpret as having religious significance. Additionally, several small chapels have been discovered throughout the underground complex, further supporting the idea that religious practices were an integral part of life in Derinkuyu. Perhaps the most compelling evidence of religious practices in Derinkuyu is the presence of a cruciform church. This spacious room, shaped like a cross, features an altar, nave, and apses, typical elements of early Christian architecture. The existence of this church suggests that Christianity had a strong presence in the underground city, likely during the Byzantine period when the region was predominantly Christian. These discoveries paint a picture of a community that valued spiritual life, even in the face of the challenges posed by living underground. The presence of religious spaces throughout Derinkuyu indicates that faith played a crucial role in the daily lives of its inhabitants, providing comfort and structure in their unique subterranean world. The underground city of Derinkuyu in Cappadocia, Turkey, provides a fascinating glimpse into how different religious groups coexisted in challenging circumstances. This subterranean marvel, carved into soft volcanic rock, served as a refuge for various communities over centuries, including early Christians, Muslims, and even some pagan groups. The design of Derinkuyu reflects the need for different religious groups to live side by side while maintaining their distinct identities. The city features separate areas that could be sealed off from one another, allowing each group to practice their faith without interference. Christian chapels, Muslim prayer rooms, and other religious spaces were incorporated into the underground structure, demonstrating a level of religious tolerance and practical coexistence. Despite potential tensions, the shared goal of survival often superseded religious differences. The threat of invasion or persecution from outside forces encouraged cooperation among the diverse inhabitants. They worked together to maintain the complex ventilation systems, water supplies, and food storage areas that were crucial for sustaining life underground. This coexistence was not always peaceful, and there were likely periods of conflict. However, the very nature of the underground city with its limited space and resources, necessitated a degree of cooperation that transcended religious boundaries. The story of Derinkuyu serves as a remarkable example of how different faith communities can adapt and coexist when faced with common challenges. Derinkuyu, the ancient underground city in Cappadocia, Turkey, contains several religious structures that reflect the spiritual practices of its inhabitants over different periods. One of the most significant religious spaces discovered in Derinkuyu is a large room believed to be a religious school. This area features a barrel-vaulted ceiling and space for students and instructors, indicating its use for religious education and training. Explorers have also uncovered a sizable cruciform church within the underground complex. This church, carved directly into the soft volcanic rock, demonstrates the presence of Christian communities in Derinkuyu during later periods of its occupation. The church includes distinct architectural elements such as apses and nave areas, typical of early Christian places of worship. Additionally, researchers have identified smaller chapels and prayer rooms scattered throughout the various levels of the underground city. These more intimate spaces likely served as areas for private worship or small group gatherings. Some of these rooms contain remnants of religious symbols and crude frescoes, though many have faded over time due to exposure and the challenging underground conditions. It is worth noting that while these Christian structures are prominent, archaeologists have also found evidence of earlier religious practices in Derinkuyu. Some rooms and symbols suggest the presence of pre-Christian belief systems, reflecting the long and diverse history of spiritual practices in this remarkable subterranean settlement. Living underground had a profound impact on the spiritual beliefs of subterranean dwellers. The constant darkness and enclosed spaces shaped their perception of the world and the divine. Many underground communities developed belief systems centered around the earth itself as a living, sacred entity. They often viewed the rock and soil surrounding them as protective guardians rather than mere geological formations. The absence of sunlight and stars led to unique creation myths and cosmologies. Instead of celestial deities, many underground cultures revered earthly spirits and unseen forces believed to inhabit the caverns and tunnels. Some groups developed intricate rituals to appease these spirits and ensure safe passage through treacherous underground pathways. The limited resources and challenging living conditions in subterranean environments also influenced religious practices. Many underground societies placed great importance on conservation and sustainable living, viewing waste and excess as spiritual transgressions. This led to the development of ascetic traditions and minimalist philosophies that permeated both their daily lives and religious observances. Furthermore, the isolation from the surface world often resulted in a strong sense of community and interconnectedness among underground dwellers. This fostered beliefs in collective consciousness and shared spiritual experiences, with many underground religions emphasizing group meditation, communal rituals, and the importance of maintaining harmony within their enclosed societies. Archaeological excavations in Derinkuyu have unearthed a wealth of artifacts that offer glimpses into the daily lives and cultural practices of its ancient inhabitants. Pottery fragments, ranging from simple cooking vessels to more ornate decorative pieces, have been discovered throughout the underground city. These ceramics not only indicate the level of craftsmanship achieved by the people of Derinkuyu, but also provide clues about their dietary habits and social customs. Researchers have also found various tools and implements made from stone and metal, suggesting a diverse range of occupations and activities within the subterranean community. Agricultural tools point to farming practices, while weaving implements indicate textile production. The presence of oil lamps and candle holders throughout the underground spaces sheds light on how the inhabitants illuminated their surroundings. Religious artifacts have been particularly enlightening, revealing the spiritual beliefs of Derinkuyu's residents. Christian symbols and small chapel areas indicate that the city served as a refuge for early Christians. Crosses carved into walls and stone altars provide evidence of religious practices conducted in secret during times of persecution. Perhaps most intriguing are the remnants of an advanced ventilation system and water management infrastructure. Stone wheels used to seal entrances, along with elaborate networks of air shafts and water channels, demonstrate the engineering prowess of the ancient inhabitants and their ability to create a sustainable underground living environment. The inhabitants of the underground city faced unique challenges in preserving their cultural heritage. Living beneath the surface required significant adaptations, but the community was determined to keep their traditions alive. They developed innovative ways to celebrate festivals and rituals in the confined spaces of their subterranean home. One key strategy was the use of advanced holographic technology to recreate the sights and sounds of their former above-ground celebrations. This allowed them to experience the illusion of open spaces and natural environments, helping to maintain a connection to their past. The city's central cavern became a focal point for large gatherings, with its high ceiling providing a sense of openness that was otherwise lacking. Education played a crucial role in cultural preservation. The elders of the community established schools dedicated to teaching traditional arts, music, and storytelling. These institutions ensured that younger generations grew up with a strong sense of their heritage, despite never having seen the world above. Craftspeople adapted their techniques to work with materials available underground, creating new forms of art that blended ancient traditions with their current reality. Food also remained an important cultural touchstone. Hydroponic gardens and specialized breeding programs allowed the inhabitants to cultivate plants and animals similar to those from the surface. This enabled them to continue preparing traditional dishes, albeit with some creative substitutions. Communal meals became a cornerstone of social life, providing opportunities for storytelling and the passing down of oral histories. The underground city of Derinkuyu in Cappadocia, Turkey, presents a fascinating glimpse into ancient subterranean living. While our knowledge of daily life in this hidden metropolis is limited, archaeological evidence suggests that art played a significant role in the cultural and spiritual life of its inhabitants. Religious artwork, particularly Christian frescoes and symbols, adorned the walls of some chambers, indicating the importance of faith to the people who sought refuge in these underground spaces. These artistic expressions served not only as decoration, but also as a means of maintaining cultural identity and spiritual connection during periods of isolation or persecution. Craftwork was also an essential aspect of life in Derinkuyu. Artifacts discovered in the underground city reveal that residents engaged in various forms of artistic production, including pottery making and textile weaving. These practical arts were crucial for daily life and likely served as a means of trade and cultural expression. The very architecture of Derinkuyu itself can be considered a form of art. The intricate network of tunnels, rooms, and ventilation shafts demonstrates the ingenuity and creativity of its builders. This functional yet impressive design reflects the artistic vision of its creators, who transformed solid rock into a livable, multi-level underground sanctuary. In the subterranean world, funeral practices underwent significant changes to accommodate the unique challenges of life below the surface. Traditional burial methods were no longer feasible due to limited space and the need to conserve resources. Instead, communities developed new rituals that respected the dead while ensuring the well-being of the living. One common practice that emerged was the process of biomass recycling. Bodies of the deceased were carefully processed to reclaim valuable organic matter and nutrients. These elements were then used to enrich hydroponic gardens or feed into algae farms, vital for sustaining the underground food supply. This practical approach was often accompanied by ceremonies that honored the individual's life and their final contribution to the community's survival. Some underground societies adopted practices of miniaturization for physical memorials. Micro-etching techniques were used to inscribe the names and life stories of the departed onto small, durable plates. These could be displayed in communal memorial spaces without taking up precious room. Holographic technology was also employed in more advanced habitats, allowing for virtual memorial spaces where loved ones could visit and remember the deceased. In certain underground cultures, the concept of a funeral evolved into a celebration of energy transfer. The idea that the energy of the deceased was being directly converted into light and life for the community became a comforting philosophy. This perspective helped inhabitants maintain a sense of continuity and purpose in the face of loss, adapting to the stark realities of subterranean existence while preserving the human need for memorialization and grief. Derinkuyu, the ancient underground city in Cappadocia, Turkey, offers intriguing glimpses into potential educational systems and knowledge transfer among its inhabitants. While direct evidence of formal schooling is limited, the complex architecture and engineering of the subterranean network suggest a sophisticated level of knowledge that was likely passed down through generations. The construction and maintenance of Derinkuyu required advanced understanding of geology, architecture, and ventilation systems. The precise carving of rock, creation of stable living spaces, and implementation of air shafts demonstrate a high level of expertise that must have been taught and shared within the community. This transfer of knowledge was crucial for the continued expansion and upkeep of the underground city. Archaeological findings in Derinkuyu have revealed spaces that could have served as gathering areas for instruction or knowledge sharing. These communal areas might have been used for both practical training in city maintenance and for passing down cultural and historical information. The presence of what appears to be a large meeting room or classroom on the second level of the underground city further supports the idea of organized knowledge transfer. The existence of religious spaces within Derinkuyu, including a cruciform church, also suggests the presence of religious education and the transmission of spiritual knowledge. These areas likely served as centers for both worship and instruction, playing a vital role in preserving and passing down the beliefs and traditions of the community that inhabited this remarkable underground world. The isolation of underground living profoundly shaped the development of unique cultural practices among subterranean communities. Cut off from the surface world, these groups adapted to their environment in remarkable ways, creating distinct traditions and social structures. One of the most significant impacts was on their perception of time. Without the natural cycles of day and night, underground dwellers often developed alternative methods of marking the passage of time. Some communities relied on the growth cycles of fungi or the behavioral patterns of cave-dwelling creatures to structure their days and seasons. Language also evolved in unique ways in these isolated environments. Many underground societies developed specialized vocabularies to describe their surroundings, with an abundance of terms for different types of rock formations, echoes, and the quality of darkness. Some groups even developed entirely new forms of non-verbal communication, using touch or vibrations to convey messages in the pitch-black tunnels. Religious and spiritual practices were similarly influenced by the underground setting. Many subterranean cultures developed belief systems centered around the earth itself, venerating rock formations or underground water sources as deities. Others created elaborate mythologies explaining their origins and relationship to the surface world, often featuring themes of exile, protection, or hidden knowledge. Break time. 3.7s. Derinkuyu, the ancient underground city in Cappadocia, Turkey, showcases a remarkable level of technological sophistication for its time. This vast subterranean complex, believed to have been constructed between the 7th and 8th centuries BCE, demonstrates advanced engineering and architectural skills that were well ahead of their era. The city's intricate network of tunnels, rooms, and passageways extends to depths of up to 200 meters below the surface. Its builders employed clever design techniques to ensure proper ventilation, water management, and security. They created a system of thousands of ventilation shafts that allowed fresh air to circulate throughout the underground levels, even at great depths. Water management was another area where Derinkuyu's builders displayed their ingenuity. They constructed wells that were not connected to the surface, preventing potential contamination or poisoning by outside forces. These wells tapped into underground water sources, providing a secure supply for the city's inhabitants. The security features of Derinkuyu are particularly impressive. Massive stone doors, weighing up to 500 kilograms, could be rolled into place to seal off sections of the city. These doors were designed to be operated from the inside, allowing defenders to control access between different levels and areas. This sophisticated defense system, combined with the city's hidden nature, made it an extremely effective refuge during times of invasion or conflict. The ancient builders of Derinkuyu faced numerous engineering challenges in creating their vast underground city. They ingeniously tackled these problems through a combination of careful planning, resourcefulness, and advanced knowledge of geology and construction techniques. One of the primary issues they confronted was ensuring adequate ventilation throughout the subterranean network. To address this, they designed an intricate system of air shafts that connected various levels of the city to the surface. These shafts not only provided fresh air but also helped regulate temperature and humidity within the underground spaces. Structural integrity was another crucial concern. The builders expertly carved the soft volcanic rock, creating sturdy pillars and supports to prevent cave-ins. They also implemented a clever system of rolling stone doors, which could quickly seal off sections of the city for defense or to control airflow. These massive circular stones, weighing up to several hundred kilograms, were precisely balanced to be easily moved by a single person from the inside, but nearly impossible to open from the outside. Water management presented yet another challenge. The builders developed an extensive network of wells, reaching depths of over 50 meters, to access the water table. They also created channels and cisterns to collect and store rainwater, ensuring a sustainable water supply for the underground inhabitants. This sophisticated water system demonstrated their advanced understanding of hydraulics and long-term resource management. Archaeologists employ a variety of specialized tools and techniques to carefully unearth and study ancient artifacts and structures. Trowels, the quintessential tool of archaeology, allow for precise digging and scraping in small areas. These handheld implements are ideal for delicate work around fragile objects. For larger-scale excavations, shovels and pickaxes come into play, though their use is carefully controlled to avoid damaging hidden artifacts. Brushes of various sizes are essential for gently removing dirt and debris from uncovered items. Sieves and screens help archaeologists sift through excavated soil, catching small objects that might otherwise be overlooked. Modern archaeology also utilizes advanced technology. Ground-penetrating radar can reveal buried structures without disturbing the soil. Laser scanning creates detailed three-dimensional models of excavation sites. Drones equipped with cameras provide aerial surveys, offering a broader perspective of the area. Careful documentation is crucial throughout the excavation process. Archaeologists use photography, detailed note-taking, and precise measurements to record the position and context of every find. This meticulous approach ensures that valuable information about the relationships between artifacts and their surroundings is not lost during the excavation. In the harsh underground environment, the inhabitants faced unique challenges in creating and maintaining tools. With limited access to traditional materials like wood or surface metals, they had to rely on resourcefulness and adaptation. The inhabitants primarily used stone, bone, and various minerals found in their subterranean world. They developed techniques to shape these materials into useful tools, often employing the natural formations of stalactites and stalagmites as raw resources. These calcium-rich deposits could be carefully worked into durable implements. To maintain their tools, the inhabitants developed innovative methods. They used naturally occurring abrasive minerals to sharpen and refine their implements. Underground water sources, rich in minerals, were sometimes utilized in a process similar to electroplating, allowing them to strengthen and preserve their tools. The scarcity of resources led to a culture of repair and reuse. Tools were carefully maintained, with broken pieces repurposed into new implements. This sustainable approach ensured the longevity of their limited resources and fostered a deep appreciation for craftsmanship in their society. Building underground presents a host of challenges that have driven significant innovations in construction techniques. One of the primary concerns is managing the immense pressure exerted by surrounding soil and rock. To address this, engineers developed advanced tunneling methods, such as the new Austrian tunneling method, which uses the inherent strength of rock formations to create a self-supporting tunnel structure. Water management is another critical issue in underground construction. Innovative waterproofing systems and drainage techniques have been developed to keep subterranean spaces dry and structurally sound. These include the use of sophisticated membrane technologies and the implementation of complex pumping systems to remove groundwater continuously. Ventilation and air quality control have also seen remarkable advancements. Modern underground facilities employ advanced air circulation systems that not only provide fresh air but also regulate temperature and humidity. These systems often incorporate smart sensors and automated controls to maintain optimal conditions without constant human intervention. Lighting has been another area of innovation. With the development of energy-efficient LED systems and light tubes that can channel natural sunlight deep underground. These solutions not only conserve energy, but also create more comfortable and productive environments for occupants of underground spaces. The ancient architects of Derinkuyu, the remarkable underground city in Turkey, demonstrated impressive ingenuity in creating an energy-efficient living space. They utilized the natural insulating properties of the earth to maintain a stable temperature throughout the year. This design choice allowed the inhabitants to stay cool during scorching summers and warm during frigid winters without the need for additional heating or cooling systems. Ventilation was a crucial aspect of Derinkuyu's energy-efficient design. The builders created a complex network of air shafts that allowed fresh air to circulate throughout the subterranean levels. These shafts were strategically placed to take advantage of natural air currents, ensuring a constant flow of fresh air without requiring mechanical ventilation systems. Water management was another area where Derinkuyu's designers showed their efficiency. They constructed wells that tapped into underground water sources, providing a sustainable supply of fresh water to the city's inhabitants. This system eliminated the need for energy-intensive water transportation from the surface. Lighting was carefully considered in the design of Derinkuyu. The builders created light wells that allowed natural sunlight to penetrate deep into the underground structure. This ingenious feature reduced the reliance on artificial lighting, conserving energy and resources. The placement of living spaces near these light wells maximized the use of natural illumination, creating a more comfortable and energy-efficient environment for the city's residents. Derinkuyu, the ancient underground city in Turkey, showcases remarkable evidence of advanced planning and architectural design. This subterranean marvel, carved into soft volcanic rock, extends to depths of approximately 200 meters and could accommodate thousands of people. The intricate network of tunnels, rooms, and passageways reveals a sophisticated understanding of engineering and urban planning. The city features a complex ventilation system with thousands of ventilation shafts, ensuring fresh air circulation even at the deepest levels. This demonstrates a keen awareness of the importance of air quality in enclosed spaces. Water management was also expertly handled in Derinkuyu. The presence of numerous wells, some not connected to the surface, indicates a deep understanding of groundwater sources and the need for a secure water supply. Moreover, the city included large spaces for livestock, food storage areas, and communal rooms, suggesting a well-thought-out approach to sustaining a large population underground for extended periods. Perhaps most impressive is the security system built into Derinkuyu's design. Each level could be sealed off independently with large stone doors, rolled into place from the inside. This feature, combined with the narrow, low passages connecting different sections, indicates a carefully planned defense strategy against potential invaders. The inhabitants of the underground settlements faced unique challenges that required innovative adaptations of existing technologies. Lighting posed a significant hurdle, as natural sunlight was no longer available. To address this, they repurposed bioluminescent organisms, originally studied for deep-sea applications, to create sustainable light sources. These glowing bacteria and fungi were cultivated in specially designed chambers, providing a soft, constant illumination that mimicked natural daylight cycles. Water management systems, initially developed for space stations, were modified to suit the subterranean environment. Closed-loop filtration and purification methods ensured a constant supply of clean water, while sophisticated moisture reclamation technology extracted water vapor from the air, reducing the need for external water sources. Agriculture underwent a dramatic transformation as well. Hydroponic and aeroponic systems, once used primarily in research facilities, became the backbone of food production. These soilless growing methods were optimized for the limited space and resources available underground, allowing for vertical farming and efficient nutrient delivery. Communication technologies also required adaptation. The rock and soil surrounding the underground habitats interfered with traditional wireless signals. Engineers developed a network of hardwired communication lines and low-frequency transmission systems that could penetrate the geological barriers, ensuring connectivity throughout the subterranean community and with the surface. The underground city utilized a variety of ingenious lighting solutions to illuminate its subterranean spaces. One of the primary methods was the use of bioluminescent organisms, carefully cultivated and integrated into the city's architecture. These living light sources provided a soft, natural glow that mimicked daylight cycles, helping residents maintain their circadian rhythms. In addition to bioluminescence, the city employed advanced photovoltaic systems to capture and store solar energy from the surface. This stored energy powered an extensive network of energy-efficient, light-emitting diode fixtures throughout the underground complex. These lights could be adjusted to simulate different times of day, creating a more natural living environment for the inhabitants. The city also made use of fiber optic technology to channel sunlight from the surface deep into the underground spaces. This system of light pipes allowed natural light to penetrate even the lowest levels of the city, providing both illumination and a psychological connection to the world above. Lastly, the underground city incorporated luminescent materials into its construction. These materials absorbed light during high illumination periods and slowly released it during low-light hours, creating a subtle ambient glow that enhanced visibility and reduced the need for constant artificial lighting. The ancient underground city of Derinkuyu in Turkey showcases remarkable technological advancements that often surpass those found in contemporary surface dwellings. One of the most impressive features was its sophisticated ventilation system. While surface structures relied on simple windows and doors for air circulation, Derinkuyu employed a network of vertical shafts that allowed fresh air to circulate throughout the subterranean levels. This system not only provided oxygen to the deepest parts of the city, but also regulated temperature and humidity. Water management in Derinkuyu was also far more advanced than in many surface settlements. The city featured numerous wells, with at least one reaching a depth of over 60 meters. These wells were strategically placed to tap into underground water sources, ensuring a constant supply even during prolonged periods of isolation. In contrast, surface dwellings often relied on less secure water sources such as rivers or rainwater collection. Security measures in Derinkuyu were particularly sophisticated. The city incorporated massive stone doors that could be rolled into place to seal off entire sections or levels. These doors, weighing up to 500 kilograms, could be operated from the inside, providing an unparalleled level of protection against invaders. Surface dwellings of the time typically relied on simpler fortifications such as walls or watchtowers. The layout and construction of Derinkuyu also demonstrated advanced engineering knowledge. The city was built on multiple levels, connected by narrow passages that could be easily defended. This vertical expansion allowed for efficient use of space and resources, a concept that was not commonly applied in surface architecture of the period. The ability to carve out and support such extensive underground structures speaks to a level of engineering expertise that was truly remarkable for its time. Break time. 3.7s. Derinkuyu, the ancient underground city in Cappadocia, Turkey, was abandoned gradually over time rather than in a single event. The exact reasons for its abandonment are not definitively known, but several factors likely contributed to the decline of this remarkable subterranean settlement. One significant factor was the changing political landscape of the region. As the Byzantine Empire weakened and the threat of invasion decreased, the need for such extensive underground fortifications diminished. This shift occurred around the 11th century, marking the beginning of Derinkuyu's decline. Another possible reason for abandonment was the improvement in above-ground defensive technologies and strategies. As surface fortifications became more effective, the necessity for elaborate underground cities like Derinkuyu decreased. Additionally, changes in climate and agricultural practices may have made surface dwelling more appealing and sustainable. The final abandonment of Derinkuyu likely occurred in the early 20th century. The last inhabitants, local Christians, left the underground city during the population exchanges between Greece and Turkey in 1923. Since then, Derinkuyu has remained uninhabited, serving as a fascinating archaeological site and tourist attraction, offering a glimpse into the ingenuity and resilience of ancient civilizations. Derinkuyu, the ancient underground city in Turkey, continues to baffle archaeologists and historians with several unexplained aspects of its construction and use. One of the most perplexing features is the sophisticated ventilation system that runs throughout the subterranean complex. Experts are still unsure how the ancient builders managed to create such an efficient air circulation network without modern engineering knowledge. The purpose of some of the chambers within Derinkuyu also remains a mystery. While many areas have clear functions, such as living quarters and storage rooms, others defy easy explanation. Some researchers speculate that these enigmatic spaces might have served ritualistic or religious purposes, but concrete evidence is lacking. The method used to excavate such a vast underground network is another aspect that continues to puzzle experts. The sheer scale of the project, with its intricate network of tunnels and rooms spanning multiple levels, would have required advanced planning and engineering skills. How the ancient inhabitants managed this feat with primitive tools remains unclear. Furthermore, the exact timeline of Derinkuyu's construction and use is still debated. While it is believed to have been built in the 7th or 8th century BCE, the city shows signs of occupation and modification over many centuries. The reasons behind its eventual abandonment and the fate of its inhabitants are also shrouded in mystery, leaving researchers with many unanswered questions about this remarkable underground city. Derinkuyu, the ancient underground city in Turkey, continues to intrigue archaeologists and historians alike. While extensive portions of this subterranean marvel have been excavated and studied, experts believe that significant sections remain undiscovered and unexplored. The known areas of Derinkuyu span 8 levels below the surface, descending to a depth of approximately 85 meters. However, local legends and some archaeological evidence suggest the city might extend even deeper, possibly containing up to 18 levels. These unexplored areas could potentially reveal new insights into the lives of the ancient inhabitants and the full extent of their engineering capabilities. Ongoing research and careful excavation work continue to uncover new chambers, passageways, and artifacts within Derinkuyu. The complex network of tunnels and rooms presents challenges for exploration, as some areas have collapsed or become unstable over time. Additionally, the vast size of the underground complex means that comprehensive exploration is a time-consuming and resource-intensive process. The possibility of undiscovered sections in Derinkuyu fuels excitement in the archaeological community. These hidden areas might house unique architectural features, preserved artifacts, or even provide clues about the purpose and extent of this remarkable underground city. As technology advances and new exploration techniques emerge, the secrets of Derinkuyu's unexplored sections may gradually come to light, offering a deeper understanding of this ancient wonder. Derinkuyu, the ancient underground city in Turkey, has sparked numerous theories about its original purpose. One prominent idea suggests it served as a refuge during times of invasion or conflict. The complex network of tunnels and chambers could have sheltered thousands of people, along with their livestock and food supplies, for extended periods. Another theory proposes that Derinkuyu was primarily a religious center. The presence of what appears to be a missionary school and numerous places of worship hints at its potential role in spiritual practices and education. Some researchers believe it might have been used by early Christians seeking to escape persecution. Some scholars argue that Derinkuyu could have been an elaborate storage facility for food and goods. The cool, stable temperatures underground would have been ideal for preserving perishables. Additionally, the city's intricate ventilation system and water management features suggest it was designed for long-term habitation, possibly as a subterranean trading post. A more recent hypothesis posits that Derinkuyu might have been constructed as a shelter against extreme climate events. This theory is based on evidence of past volcanic activity in the region and the potential for harsh environmental conditions. Regardless of its original intent, Derinkuyu remains a testament to the ingenuity and engineering skills of ancient civilizations. Archaeologists continue to marvel at the advanced engineering displayed in the ancient underground city of Derinkuyu in Turkey. This remarkable subterranean complex, carved into the soft volcanic rock of Cappadocia, showcases the ingenuity and technical prowess of its creators. The construction of Derinkuyu, which dates back to at least the 7th or 8th century BCE, required a deep understanding of geology, architecture, and ventilation. Archaeologists explain that the builders expertly utilized the properties of the local volcanic tuff, which is soft enough to carve but hardens when exposed to air. This allowed them to create a stable, multi-level structure that could support the weight of the rock above. One of the most impressive features of Derinkuyu is its sophisticated ventilation system. The builders designed a network of over 50 ventilation shafts, some reaching depths of over 200 feet. These shafts not only provided fresh air to the lower levels, but also regulated temperature and humidity throughout the underground city. This level of environmental control demonstrates an advanced grasp of air circulation principles. The city also boasts an intricate water management system, including wells that were not connected to the surface to prevent contamination from potential enemies. Archaeologists suggest that this, along with the presence of livestock pens and food storage areas, indicates that the builders designed Derinkuyu to sustain large populations for extended periods. The complexity and foresight evident in these features continue to impress modern engineers and archaeologists, highlighting the sophisticated capabilities of ancient civilizations. Derinkuyu, the ancient underground city in Turkey, shares intriguing connections with other archaeological enigmas around the world. This vast subterranean complex, carved into the soft volcanic rock of Cappadocia, bears similarities to other underground structures found in various cultures. One notable connection is with the extensive tunnel systems discovered beneath the Giza Plateau in Egypt. Like Derinkuyu, these tunnels suggest advanced engineering capabilities in ancient times, challenging our understanding of early civilizations. Both sites feature complex ventilation systems and water management, indicating a sophisticated level of planning and construction. Derinkuyu also draws parallels with the mysterious city of Petra in Jordan. While Petra is carved into cliff faces rather than underground, both sites demonstrate remarkable skill in working with rock to create livable spaces. The ingenuity required to build these cities points to a shared human drive to adapt to and manipulate challenging environments. Furthermore, the purpose of Derinkuyu as a refuge from external threats echoes the function of other ancient sites, like the Mesa Verde cliff dwellings in Colorado. This recurring theme of creating defensible spaces suggests a common human response to societal pressures across different cultures and time periods, linking these ancient mysteries through shared human experiences and ingenuity. Derinkuyu, the ancient underground city in Turkey, continues to intrigue archaeologists and historians with its complex network of tunnels and chambers. While much of the city has been explored and documented, there are indeed some unexplained features that have puzzled researchers. One of the most perplexing elements is the purpose of certain rooms and passageways. Some chambers appear to have been designed for specific functions that remain unclear to modern observers. For instance, there are large, circular rooms with high ceilings that don't seem to fit the pattern of living quarters or storage areas. Some experts speculate these might have been used for religious ceremonies or gatherings, but their exact purpose remains a mystery. Another unexplained feature is the sophisticated ventilation system that runs throughout the underground city. While its function is clear, the advanced engineering required to create such an efficient air circulation system in ancient times has left many experts wondering about the technical knowledge of its builders. Additionally, there are some unusual stone artifacts found within Derinkuyu that don't match the typical tools or household items expected in such a settlement. These objects, whose purposes remain unknown, have led to various theories about the daily life and practices of the people who once inhabited this subterranean world. The mystery surrounding Derinkuyu's construction poses a significant challenge for researchers studying this ancient underground city in Turkey. The absence of historical records detailing its creation has led archaeologists and historians to rely heavily on physical evidence and comparative analysis with other subterranean structures in the region. Experts have turned to advanced dating techniques to establish a timeline for Derinkuyu's development. By examining artifacts found within the complex and analyzing the wear patterns on the carved rock surfaces, researchers can estimate when different sections were excavated and inhabited. This approach, combined with geological studies of the local rock formations, helps paint a clearer picture of the city's evolution over time. Another method researchers employ is the study of cultural and architectural similarities between Derinkuyu and other known settlements in Cappadocia. By identifying common features and construction techniques, experts can infer shared knowledge and potentially trace the origins of the underground city's design. This comparative approach also helps in understanding the broader context of subterranean living in the region. Oral traditions and folklore from local communities provide additional clues, though these must be carefully evaluated for historical accuracy. While not as reliable as physical evidence, these stories can offer insights into the purpose and use of Derinkuyu throughout its history, helping researchers form hypotheses about its construction and the motivations behind its creation. The ancient underground city of Derinkuyu, located in Cappadocia, Turkey, has long captured the imagination of historians and archaeologists. This vast subterranean complex, carved into soft volcanic rock, likely played a significant role in shaping local myths and legends throughout history. Derinkuyu's extensive network of tunnels, chambers, and ventilation shafts could have inspired tales of underground realms and hidden civilizations. Its ability to house thousands of people, along with their livestock and supplies, might have given rise to stories of entire societies living beneath the Earth's surface. The city's intricate defensive systems, including massive stone doors that could seal off sections from intruders, may have contributed to legends of impenetrable fortresses and safe havens during times of conflict. These features could have been incorporated into local folklore as examples of ingenious engineering or divine protection. Furthermore, Derinkuyu's mysterious origins and purpose might have fueled speculation about its creators. Some may have attributed its construction to supernatural beings or ancient advanced civilizations, weaving fantastical narratives that persisted through generations. These legends could have intertwined with existing mythologies, creating a rich tapestry of stories that continue to captivate us today. Derinkuyu, the ancient underground city in Cappadocia, Turkey, indeed presents several intriguing anomalies that challenge our conventional understanding of ancient civilizations. This vast subterranean complex, carved into soft volcanic rock, extends to depths of approximately 200 meters and could reportedly accommodate up to 20,000 people. One of the most perplexing aspects of Derinkuyu is its sophisticated ventilation system. The city features a complex network of air shafts that reach from the surface to the deepest levels, ensuring a constant supply of fresh air throughout the structure. This level of engineering prowess in ancient times raises questions about the technological capabilities of its builders. Another anomaly is the presence of moving stone doors weighing up to 500 kilograms, which could be closed from the inside to seal off sections of the city. These doors demonstrate an advanced understanding of defensive architecture and stoneworking techniques that seem ahead of their time. Additionally, the city's water management system, including wells that were not connected to the surface to prevent poisoning by enemies, showcases a level of strategic planning and hydraulic knowledge that challenges our perceptions of ancient engineering. The sheer scale and complexity of Derinkuyu also pose questions about the social organization and labor management required to create such a massive underground structure. This challenges our understanding of the capabilities of ancient societies in terms of project planning, resource allocation, and long-term communal efforts. The existence of Derinkuyu and other similar underground cities in the region continues to intrigue archaeologists and historians, prompting ongoing research into the advanced capabilities of our ancient ancestors. Break time 3.7s. The modern entrance to Derinkuyu, the ancient underground city in Turkey, was discovered in 1963 by a local resident. This man was renovating his home when he accidentally knocked down a wall, revealing a mysterious passageway. This passageway led to a vast network of underground tunnels and rooms, which we now know as Derinkuyu. The discovery was entirely unexpected and sent shockwaves through the archaeological community. Derinkuyu turned out to be one of the largest and most complex underground cities ever found. It spans several levels, descending more than 200 feet below the surface of Cappadocia. Archaeologists and historians were amazed by the sophistication of this subterranean marvel. Derinkuyu featured living quarters, storage rooms, religious spaces, and even wineries. It had intricate ventilation systems and could reportedly accommodate up to 20,000 people. This chance discovery opened up a new chapter in our understanding of ancient civilizations. It revealed the ingenuity and resourcefulness of our ancestors, who created this hidden city as a refuge from invaders and harsh weather conditions. The unveiling of Derinkuyu has since inspired further explorations in the region, leading to the discovery of other underground cities in Cappadocia. The rediscovery of Derinkuyu, the ancient underground city in Turkey, occurred in 1963 under rather serendipitous circumstances. A local resident was renovating his home when he stumbled upon a mysterious room hidden behind a wall. This discovery sparked curiosity and led to further exploration, revealing an extensive network of subterranean chambers and passageways. As excavations progressed, archaeologists uncovered a vast underground complex spanning several levels. Derinkuyu turned out to be one of the largest and most sophisticated underground cities ever found. The complex included living quarters, storage areas, communal spaces, and even religious chambers, all ingeniously designed to support a sizable population for extended periods. The circumstances surrounding Derinkuyu's rediscovery highlight the often unexpected nature of archaeological finds. This chance encounter with a hidden room opened up a window into the past, shedding light on the ingenuity and resilience of ancient civilizations. The discovery also underscores the potential for significant historical sites to remain hidden for centuries, even in areas of long human habitation. Derinkuyu's rediscovery has since led to increased interest in and exploration of other underground structures in the Cappadocia region. This has expanded our understanding of how ancient peoples adapted to challenging environments and threats, creating elaborate subterranean refuges that continue to astound us today. The initial excavation of Derinkuyu, the ancient underground city in Cappadocia, Turkey, was a complex and time-consuming process. Archaeologists began their work in 1963 after the site was accidentally discovered by a local resident renovating his home. The excavation efforts continued for nearly 2 decades, with major portions of the underground complex revealed by the early 1980s. During this period, researchers uncovered an intricate network of tunnels, rooms, and passages spanning multiple levels beneath the surface. The sheer scale of Derinkuyu surprised even experienced archaeologists, as they gradually unearthed a vast subterranean world capable of sheltering thousands of people. The excavation process was challenging due to the delicate nature of the soft volcanic rock in which Derinkuyu was carved. Archaeologists had to work carefully to avoid damaging the ancient structures while removing centuries of accumulated debris and sediment. As they dug deeper, they discovered an elaborate system of ventilation shafts, water channels, and defensive mechanisms that spoke to the ingenuity of the ancient builders. While the initial excavation phase lasted about 20 years, it is important to note that work at Derinkuyu continues to this day. Archaeologists and researchers are still studying the site, uncovering new areas, and gaining fresh insights into the lives of those who once inhabited this remarkable underground city. Archaeologists encountered numerous obstacles during excavations, testing their skills and determination. The unpredictable nature of buried artifacts and structures often required them to adapt their methods on the fly. Delicate items like pottery shards or ancient textiles demanded extreme care to prevent damage during removal. Adverse weather conditions frequently hampered progress, with rain turning dig sites into muddy quagmires and extreme heat causing dehydration among team members. In some locations, political instability or local conflicts restricted access to important sites, forcing researchers to work within limited timeframes or under heightened security measures. The sheer physical demands of excavation work took a toll on archaeologists. Hours of careful digging, often in cramped or awkward positions, led to fatigue and strain injuries. Additionally, the risk of disturbing or misinterpreting the archaeological record loomed large, as even small mistakes could lead to incorrect conclusions about past civilizations. Funding constraints posed another significant challenge, limiting the scope and duration of many excavations. Archaeologists often had to balance their scientific goals with budget realities, making difficult decisions about which areas to prioritize and which to leave unexplored for future generations. The excavation of Derinkuyu, an ancient underground city in Turkey, revealed a complex network of subterranean chambers and passageways that astounded archaeologists. This vast underground metropolis, carved into the soft volcanic rock of Cappadocia, was found to be much larger and more sophisticated than initially believed. One of the most surprising discoveries was the sheer scale of Derinkuyu. The city extends to depths of over 200 feet, with at least 18 levels identified so far. This makes it one of the largest and deepest underground settlements ever found. Researchers were amazed to find that the city could potentially accommodate up to 20,000 people, complete with living quarters, storage areas, and communal spaces. Another unexpected finding was the advanced ventilation system employed throughout Derinkuyu. The ancient builders created a network of over 15,000 ventilation shafts, ensuring a constant supply of fresh air even in the deepest levels of the city. This engineering feat demonstrated a level of technological understanding that was far ahead of its time. Perhaps most intriguing was the discovery of sophisticated security measures throughout the complex. Massive stone doors, weighing up to 1,000 pounds each, could be rolled into place to seal off sections of the city in case of invasion. These doors could only be operated from the inside, providing the inhabitants with a formidable defense against outside threats. This level of strategic planning and engineering prowess shed new light on the advanced capabilities of ancient civilizations and their ability to create safe havens in seemingly inhospitable environments. Modern technology has revolutionized the exploration of Derinkuyu, the ancient underground city in Turkey. Ground-penetrating radar has allowed archaeologists to map the extent of the subterranean network without disturbing the delicate structures. This non-invasive technique has revealed previously unknown chambers and passages, expanding our understanding of the city's layout and complexity. Three-dimensional laser scanning technology has been employed to create detailed digital models of Derinkuyu. These models provide researchers with precise measurements and allow for virtual exploration of areas too fragile or narrow for human access. The scans also aid in preservation efforts by documenting the current state of the site and identifying areas in need of conservation. Environmental sensors placed throughout the underground city monitor temperature, humidity, and air quality. This data helps archaeologists understand the conditions that have preserved Derinkuyu for centuries and informs strategies to protect it from degradation. Additionally, advanced dating techniques, such as optically stimulated luminescence, have refined our estimates of when different sections of the city were constructed and used. Drone technology has been utilized to survey the surface area above Derinkuyu. identifying potential new entrances and mapping the relationship between the underground city and the surrounding landscape. This aerial perspective has provided valuable context for understanding how the ancient inhabitants might have used and accessed the subterranean refuge. Derinkuyu, the ancient underground city in Turkey, requires careful preservation techniques during ongoing excavations to protect its delicate structures. Archaeologists employ a range of methods to safeguard this remarkable site as they continue to uncover its secrets. One key approach involves controlling the environment within the underground chambers. Humidity and temperature are closely monitored and regulated to prevent damage to the ancient stone surfaces. Specialized equipment is used to maintain optimal conditions, reducing the risk of erosion or mold growth that could compromise the integrity of the site. Structural reinforcement is another crucial aspect of preservation. Engineers work alongside archaeologists to assess the stability of tunnels and rooms, implementing support systems where necessary. This might include the careful installation of modern materials that blend seamlessly with the original construction, ensuring the city's layout remains authentic while preventing collapse. Documentation plays a vital role in preservation efforts. Every newly excavated area is meticulously recorded using advanced imaging techniques, including three-dimensional scanning. This creates a comprehensive digital archive, allowing researchers to study the site without causing further disturbance and providing a blueprint for potential future restoration work. Excavation techniques have undergone significant advancements since the initial discovery of Derinkuyu, the ancient underground city in Turkey. In the early days, archaeologists relied heavily on manual labor, using basic tools like shovels, pickaxes, and brushes to carefully unearth artifacts and structures. This painstaking process was time-consuming and limited the scope of excavations. As technology progressed, archaeologists incorporated more sophisticated tools into their work. Ground-penetrating radar became a game-changer, allowing researchers to map underground structures without disturbing the soil. This non-invasive technique helped identify potential areas of interest and guided excavation efforts more efficiently. Digital mapping and three-dimensional modeling have revolutionized the documentation process. These technologies enable archaeologists to create detailed, accurate representations of excavation sites, preserving information for future study and analysis. Additionally, advanced dating methods, such as radiocarbon dating and thermoluminescence, have improved our ability to determine the age of artifacts and structures with greater precision. The integration of drones and aerial photography has provided archaeologists with a broader perspective of excavation sites. These tools help identify patterns and features that might not be visible from the ground, offering valuable insights into the layout and organization of ancient settlements like Derinkuyu. As excavation techniques continue to evolve, our understanding of these remarkable underground cities grows, shedding light on the ingenuity of our ancestors. Derinkuyu, the ancient underground city in Cappadocia, Turkey, continues to intrigue archaeologists and historians. While significant portions of this subterranean marvel have been uncovered, substantial areas remain unexplored. The lower levels of Derinkuyu, believed to extend to depths of up to 200 meters, are largely unexcavated. These deeper regions potentially hold valuable insights into the city's full extent and the lives of its ancient inhabitants. Several factors contribute to the incomplete excavation of Derinkuyu. The complex network of tunnels and chambers poses significant challenges for archaeologists. Some passages have collapsed or become unstable over time, making exploration dangerous and requiring careful planning and safety measures. Additionally, the presence of groundwater in the lower levels complicates excavation efforts, necessitating advanced drainage and preservation techniques. Limited resources and funding also play a role in the incomplete exploration of Derinkuyu. Archaeological projects often require substantial financial support and specialized equipment, which may not always be readily available. Furthermore, the Turkish government carefully regulates excavations to balance research interests with the preservation of this unique historical site. Unexcavated areas of Derinkuyu might contain undiscovered chambers, artifacts, or even connections to other underground cities in the region. As technology advances and resources become available, future excavations could reveal new insights into the ingenuity of ancient civilizations and their remarkable underground dwellings. The understanding of Derinkuyu, the ancient underground city in Turkey, has evolved significantly since its rediscovery in 1963. Initially, archaeologists believed it was primarily a temporary refuge for inhabitants during times of conflict. However, extensive research and excavations have revealed a far more complex and permanent settlement. Recent studies indicate that Derinkuyu was not just a shelter, but a fully functioning subterranean city. Archaeologists have uncovered evidence of long-term habitation, including sophisticated ventilation systems, water wells, and storage areas for food. This suggests that people lived in these underground spaces for extended periods, not just during emergencies. Another significant change in our understanding is the scale of Derinkuyu. Early estimates suggested it could house several thousand people, but current research indicates it may have accommodated up to 20,000 inhabitants. The discovery of multiple levels, extending to depths of over 200 feet, has expanded our perception of its size and complexity. Furthermore, the purpose of Derinkuyu has been re-evaluated. While defense was certainly a factor, scholars now believe it also served religious and commercial functions. The presence of churches, schools, and what appear to be shops and workshops points to a diverse, self-sustaining community. This new perspective has transformed our view of ancient Cappadocian society and its ability to adapt to challenging environments. Break time 3.7. Derinkuyu stands out as one of the largest and most impressive underground cities ever discovered. Located in the Cappadocia region of Turkey, this subterranean marvel extends to a depth of approximately 250 feet below the surface, spanning 8 distinct levels. While exact measurements are challenging due to the complex nature of underground structures, experts estimate that Derinkuyu could have accommodated between 20,000 and 50,000 inhabitants. Compared to other known underground cities, Derinkuyu is truly massive. For instance, the nearby Kaymakli underground city, also in Cappadocia, is only about half the size of Derinkuyu in terms of depth and capacity. Derinkuyu's extensive network of tunnels, rooms, and passages far surpasses most other underground settlements discovered to date. However, it is worth noting that new underground cities are still being discovered, and our understanding of their relative sizes may change. In 2015, another large underground city was found in the Nevşehir province of Turkey, which some researchers believe might rival or even exceed Derinkuyu in size. This recent discovery underscores the fact that there may be even larger underground cities waiting to be unearthed. While Derinkuyu remains one of the most extensive known underground cities, its true significance lies not just in its size, but in its sophisticated design and the insights it provides into ancient engineering and communal living strategies. Derinkuyu, the ancient underground city in Turkey, boasts several unique features that set it apart from other subterranean structures. One of its most remarkable elements is its extensive ventilation system. This network of thousands of ventilation shafts not only provided fresh air to the depths of the city, but also regulated temperature and humidity, creating a livable environment for its inhabitants up to 200 meters below the surface. Another distinctive aspect of Derinkuyu is its sophisticated security measures. The city features large stone doors that could be rolled into place to seal off sections or entire floors, providing protection against invaders. These doors were designed to be operated only from the inside, giving the inhabitants control over access to different areas of the city. Derinkuyu also contains a unique water management system. It includes wells that were not connected to the surface, preventing contamination or poisoning by outsiders. This system allowed the underground population to access fresh water without risking exposure to potential threats above ground. The city's multi-level structure is another standout feature. With at least 8 floors, and possibly as many as 18, Derinkuyu could accommodate thousands of people along with their livestock and food stores. This vertical layout, combined with its sophisticated systems, made Derinkuyu a self-contained underground world capable of sustaining life for extended periods, a feature rarely seen in other underground structures of its time. Derinkuyu, located in the Cappadocia region of Turkey, stands out among subterranean cities due to its unique and intricate design. Unlike many underground structures that consist of simple caves or tunnels, Derinkuyu is a complex, multi-level city carved into soft volcanic rock. One of the most distinctive features of Derinkuyu is its vertical layout. The city descends to a depth of approximately 200 meters, with 8 distinct levels connected by narrow passageways. This vertical orientation allowed for efficient use of space and provided multiple layers of security against invaders. Derinkuyu also boasts an advanced ventilation system, a crucial element not commonly found in other underground settlements. A network of over 50 ventilation shafts ensures fresh air circulation throughout the city, even at its deepest levels. This engineering feat allowed thousands of people to inhabit the underground city for extended periods. Another unique aspect of Derinkuyu is its sophisticated security measures. The city features large stone doors that could be rolled into place to seal off each level, providing protection against threats. Additionally, each floor had water wells that were not connected to the surface, preventing potential contamination by enemies. These features demonstrate the advanced planning and engineering that went into Derinkuyu's construction, setting it apart from many other subterranean structures of its time. Derinkuyu shares several key features with other underground cities in Cappadocia, Turkey. These subterranean marvels were all carved into the soft volcanic rock that characterizes the region, creating vast networks of tunnels and chambers. Like Derinkuyu, many of these underground settlements feature multiple levels, sometimes extending 8 or more stories below the surface. They all incorporate sophisticated ventilation systems, ensuring a steady flow of fresh air even in the deepest chambers. Water management was also a common concern, with wells and water channels carefully designed to provide a reliable supply. Security was paramount in these underground havens. Most feature narrow, easily defensible entrances and a system of rolling stone doors that could quickly seal off sections of the city. Storage areas for food and livestock were common, allowing inhabitants to survive extended periods underground. The underground cities of Cappadocia, including Derinkuyu, also share a history of use by early Christians seeking refuge from persecution. Many contain spaces that appear to have been used as churches or gathering areas, highlighting their importance as sanctuaries for religious communities. Derinkuyu, the remarkable underground city in Turkey, is a testament to ancient engineering and ingenuity. Dating back to around the 7th or 8th century BCE, this subterranean marvel is relatively young compared to some of the oldest known underground structures. For instance, the hypogeum of Hal Saflieni in Malta predates Derinkuyu by several millennia. This ancient underground temple complex was carved into solid limestone around 3600 BCE, making it over 5,000 years old. Similarly, the Tomb of Newgrange in Ireland, constructed around 3200 BCE, is significantly older than Derinkuyu. However, when compared to other underground cities, Derinkuyu stands out for its scale and complexity. While many ancient cultures created underground chambers or tunnels, few match the intricate multi-level design of Derinkuyu. The Lalibela rock-hewn churches in Ethiopia, dating to the 12th and 13th centuries CE, are more recent examples of large-scale underground construction. Derinkuyu's age becomes particularly impressive when we consider its sophisticated ventilation system, water management, and defensive features. These elements showcase a level of technological advancement that was ahead of its time, even if the structure itself is not among the oldest underground constructions in the world. The ancient underground city of Derinkuyu in Turkey offers fascinating insights into the development of subterranean architecture. This remarkable site, carved into soft volcanic rock, extends to depths of over 200 feet and could accommodate thousands of people. Derinkuyu reveals the ingenuity of ancient engineers in creating functional living spaces below ground. The city features an intricate network of tunnels, rooms, and vertical shafts that provided ventilation and connected different levels. This sophisticated design demonstrates a deep understanding of air circulation and structural integrity in underground construction. The city also showcases advanced security measures. Massive stone doors could be rolled into place to seal off sections or entire levels, protecting inhabitants from external threats. This aspect of Derinkuyu's design highlights how underground architecture evolved not just for living space, but as a means of defense and survival. Perhaps most importantly, Derinkuyu illustrates the potential for sustainable underground living. The constant temperature below ground provided natural climate control, while water wells ensured a steady supply of fresh water. These features point to the long-term viability of underground settlements and offer valuable lessons for modern sustainable architecture. Derinkuyu, the ancient underground city in Turkey, stands out among subterranean settlements due to its unique design and extensive defensive capabilities. Unlike many other underground structures built primarily for shelter or storage, Derinkuyu was engineered as a fully functional city that could sustain life for extended periods. The purpose of Derinkuyu was multifaceted, serving as both a refuge and a permanent dwelling place. Its intricate network of tunnels, rooms, and ventilation shafts allowed thousands of people to live comfortably below ground. This level of sophistication surpasses many other underground cities, which were often simpler in design and intended for shorter-term use. One of the most distinctive features of Derinkuyu is its elaborate security system. Massive stone doors could be rolled into place to seal off sections of the city, protecting inhabitants from invaders. This advanced defensive strategy sets Derinkuyu apart from other underground settlements that might have relied more on concealment than active defense. Furthermore, Derinkuyu incorporated spaces for various aspects of daily life, including areas for food production, animal keeping, and religious practices. This comprehensive approach to underground living demonstrates a level of planning and foresight that exceeds that of many other subterranean structures, which often focused on more limited functions such as storage or temporary refuge. Comparisons between Derinkuyu and other underground cities have revealed remarkable insights into ancient engineering practices. These subterranean marvels showcase the ingenuity and technical prowess of our ancestors, demonstrating their ability to create complex, livable spaces deep within the earth. One key insight is the sophisticated ventilation systems found in Derinkuyu and similar sites. Engineers of the past devised clever methods to circulate air through multiple levels, ensuring a steady supply of oxygen even in the deepest chambers. This feat required a deep understanding of airflow dynamics and the ability to plan intricate networks of shafts and tunnels. Water management techniques have also been a point of comparison. Derinkuyu features wells that reach impressive depths, accessing underground water sources. Similar systems have been observed in other underground cities, highlighting the crucial role of water access in sustaining large populations below ground. These ancient engineers demonstrated an advanced grasp of hydrogeology, identifying and tapping into aquifers with remarkable precision. Security measures provide another area of fascinating comparison. Derinkuyu and its counterparts often feature intricate defensive systems, including rolling stone doors and narrow passageways. These elements suggest a shared concern for protection against external threats and indicate a sophisticated approach to urban planning that prioritized both functionality and safety in these underground environments. The discovery of Derinkuyu, the ancient underground city in Turkey, has significantly impacted archaeological research and sparked a renewed interest in subterranean structures worldwide. This vast complex, carved into soft volcanic rock, has inspired archaeologists and historians to re-evaluate potential underground sites in other regions. Derinkuyu's intricate network of tunnels, rooms, and ventilation shafts has provided valuable insights into ancient engineering and urban planning. These findings have led researchers to develop new techniques for identifying and exploring similar underground structures. Ground-penetrating radar, and other advanced technologies are now routinely employed to detect hidden cavities and potential underground settlements. The existence of Derinkuyu has also prompted a reassessment of historical records and local legends that mention underground dwellings. Many areas previously dismissed as mere folklore are now being investigated with renewed vigor. This has resulted in the discovery of several other underground cities in the Cappadocia region of Turkey, as well as potential sites in other parts of the world. Furthermore, the study of Derinkuyu has enhanced our understanding of how ancient civilizations adapted to harsh environments and threats. This knowledge is guiding archaeologists in their search for similar adaptive strategies in other cultures, potentially leading to the discovery of more underground settlements in diverse geographical locations. The ancient underground city of Derinkuyu in Turkey offers valuable insights for modern underground construction. Its ingenious design and efficient use of space provide inspiration for creating sustainable and secure subterranean structures today. One key lesson from Derinkuyu is the importance of ventilation. The city featured a sophisticated network of air shafts that allowed fresh air to circulate throughout the underground levels. This system ensured a constant supply of oxygen and regulated temperature, crucial factors for any modern underground facility. Derinkuyu also demonstrates the potential for vertical expansion in underground construction. The city extended over 18 levels below the surface, showcasing how limited horizontal space can be maximized through downward development. This approach could be particularly useful in urban areas where surface space is at a premium. The ancient city's water management system is another aspect relevant to modern construction. Derinkuyu had wells that were not connected to the surface, protecting the water supply from contamination or enemy manipulation. This strategy of securing essential resources within the underground structure itself is applicable to modern underground shelters or long-term habitation spaces. Break time 3.7s. Derinkuyu, the ancient underground city in Turkey, is a remarkable testament to human ingenuity and resilience. To safeguard this unique historical site, Turkish authorities have implemented several conservation measures. The Ministry of Culture and Tourism oversees the protection of Derinkuyu, working to maintain its structural integrity and historical authenticity. One key preservation strategy involves controlling visitor access. The number of tourists allowed into the underground complex at any given time is carefully regulated to prevent excessive wear and tear on the ancient structures. Additionally, certain areas of the city remain off-limits to the public, allowing archaeologists and conservationists to conduct research and preservation work without interference. Climate control is another crucial aspect of Derinkuyu's preservation. The natural temperature and humidity levels within the underground city are monitored and maintained to prevent degradation of the rock-cut structures and any remaining artifacts. Specialized ventilation systems have been installed to regulate air quality and circulation throughout the accessible areas. Ongoing research and documentation efforts also play a vital role in preserving Derinkuyu for future generations. Archaeologists and historians continue to study the site, uncovering new information about its construction, use, and historical significance. This knowledge not only enhances our understanding of the past, but also informs future conservation strategies, ensuring that Derinkuyu remains a window into ancient Cappadocian life for years to come. Tourism has played a significant role in both the preservation and challenges faced by Derinkuyu, the ancient underground city in Turkey. As visitors flocked to explore this remarkable subterranean marvel, increased awareness and revenue have contributed to conservation efforts. The income generated from tourism has allowed for improved maintenance and restoration of the site, helping to protect its intricate network of tunnels, rooms, and ventilation shafts. However, the influx of tourists has also brought about new pressures on this delicate historical site. The constant foot traffic through the narrow passageways and chambers has led to wear and tear on the ancient structures. Moisture from human breath and touch can potentially damage the porous rock, while vibrations from large groups moving through the tunnels may cause subtle structural stresses over time. To address these concerns, authorities have implemented measures to balance preservation with public access. Visitor numbers are now regulated, and certain areas of Derinkuyu are closed off to the public on a rotating basis to allow for restoration work. Additionally, guided tours help ensure that visitors follow designated paths and adhere to preservation guidelines. Despite these challenges, tourism has ultimately been beneficial for Derinkuyu. It has brought international attention to this extraordinary example of ancient engineering, fostering a greater appreciation for its historical and cultural significance. This increased recognition has led to more resources being allocated for its study and preservation, ensuring that future generations can continue to marvel at this underground wonder. Derinkuyu, the ancient underground city in Cappadocia, Turkey, offers visitors a fascinating glimpse into subterranean life. Today, tourists can explore approximately 10% of this vast complex, which extends to a depth of about 85 meters. The accessible areas include several levels of the city, showcasing its ingenious design and the daily life of its former inhabitants. Visitors can wander through narrow passageways connecting various chambers, including living quarters, storage rooms, and communal spaces. One of the most impressive features open to the public is the large ventilation shaft, which not only provided air circulation, but also served as a well, ensuring a water supply for the underground dwellers. Tourists can also see the remains of wine and oil presses, stables, cellars, and storage rooms, offering insights into the self-sufficiency of the underground community. The reasons for limiting tourist access to only a portion of Derinkuyu are multifaceted. Primarily, it is a matter of safety and preservation. Many areas of the ancient city remain unstable or require further archaeological study and restoration. By restricting access, authorities can better protect both visitors and the historical site itself. Additionally, controlled tourism helps prevent damage from foot traffic and human interaction, ensuring that future generations can continue to learn from and marvel at this extraordinary underground world. Despite the limited access, the open sections of Derinkuyu provide ample opportunity for visitors to experience the ingenuity and resilience of its ancient inhabitants. The accessible areas offer a comprehensive understanding of how people lived, worked, and protected themselves in this subterranean city, making it a captivating destination for history enthusiasts and curious travelers alike. Balancing tourism and archaeological research is a complex challenge for authorities worldwide. Many historical sites serve dual purposes as tourist attractions and active research areas, requiring careful management to preserve their integrity while allowing public access. One key strategy is implementing controlled access to sensitive areas. Authorities often restrict certain parts of archaeological sites, permitting only researchers to enter while directing tourists to designated viewing areas. This approach allows excavations and studies to continue undisturbed while still offering visitors a meaningful experience. Another important tactic is the use of timed entry systems and visitor caps. By limiting the number of people allowed on site at any given time, authorities can reduce wear and tear on fragile structures and artifacts. This also creates a more enjoyable experience for tourists, as overcrowding can detract from the site's atmosphere and educational value. Education plays a crucial role in this balancing act. Many sites now incorporate interactive exhibits, guided tours, and informative displays that explain ongoing research. This not only enhances the visitor experience, but also fosters public appreciation for archaeological work, potentially leading to increased support for conservation efforts and future studies. Derinkuyu, the ancient underground city in Turkey, faces significant challenges as tourism continues to grow. The influx of visitors puts immense pressure on the delicate structures and environment of this historical marvel. Foot traffic from thousands of tourists each year causes gradual erosion of the soft volcanic rock, slowly wearing away the very foundations of the city. Increased humidity from human breath and body heat poses another threat to Derinkuyu. This moisture can lead to the growth of mold and bacteria, potentially damaging ancient artifacts and weakening structural integrity. The constant touching of walls and carvings by curious visitors also contributes to the deterioration of these irreplaceable features. Waste management becomes a critical issue with higher tourist numbers. Improper disposal of trash and the difficulty of maintaining cleanliness in such a confined space can lead to pollution and health hazards. Additionally, the need for modern amenities to accommodate visitors, such as lighting and ventilation systems, may require alterations to the original structure, potentially compromising its authenticity. Conservation efforts must balance the desire to share this remarkable site with the world against the need to preserve it for future generations. Implementing strict visitor quotas, guided tours, and protective barriers around sensitive areas are some measures being considered to mitigate these challenges and ensure the long-term survival of Derinkuyu. Stonehenge has undergone careful modifications to enhance visitor safety while preserving its archaeological integrity. The ancient stone circle is now roped off to prevent direct contact, protecting the stones from erosion and vandalism. This measure allows visitors to appreciate the monument from a respectful distance without risking damage to the fragile structures. A paved pathway encircles the monument, providing stable footing for visitors and wheelchair users alike. This addition improves accessibility without disturbing the archaeological layers beneath. Discrete information boards have been strategically placed along the path, offering historical context and safety guidelines without obstructing views of the stones. The visitor center, located 1.5 miles from the stone circle, serves as a hub for safety briefings and educational displays. By situating modern facilities away from the monument, the historical atmosphere of Stonehenge remains undisturbed. Shuttle buses transport visitors between the center and the stones, reducing foot traffic and potential erosion of the surrounding landscape. Environmental monitoring systems have been discreetly installed to track the impact of visitors and weather conditions on the site. These tools allow conservators to make informed decisions about site management, ensuring long-term preservation while maintaining public access to this remarkable piece of human history. Derinkuyu, the ancient underground city in Cappadocia, Turkey, has become a focal point for educational tourism. The Turkish Ministry of Culture and Tourism has implemented comprehensive guided tours that offer visitors in-depth insights into the historical and cultural significance of this remarkable subterranean complex. These tours are led by knowledgeable local guides who explain the intricate network of tunnels, rooms, and ventilation shafts that make up the city. Many of these educational programs focus on the ingenious architectural and engineering features of Derinkuyu. Visitors learn about the sophisticated ventilation system that allowed thousands of people to live underground for extended periods, as well as the security measures designed to protect inhabitants from invaders. The tours also highlight the daily life of the ancient residents, showcasing areas such as living quarters, storage rooms, and communal spaces. To enhance the learning experience, some tour operators have incorporated interactive elements into their programs. These may include hands-on demonstrations of ancient tools and techniques used to carve out the soft volcanic rock, or reenactments of historical events that took place in the underground city. Additionally, many tours now utilize modern technology, such as augmented reality apps, to provide visitors with visual reconstructions of how the city might have looked when it was fully inhabited. Furthermore, local museums and cultural centers in the Cappadocia region offer complimentary exhibitions and workshops that provide broader context for Derinkuyu and its place in the rich history of the area. These educational initiatives aim to create a comprehensive understanding of the underground city, its creators, and its enduring importance in Turkish and world history. The local community in Cappadocia, Turkey, has played a crucial role in preserving and promoting Derinkuyu, the ancient underground city. Residents of the area have long been aware of the historical significance of this remarkable subterranean network, passing down knowledge and stories through generations. In recent decades, as tourism to the region has increased, local guides have become instrumental in sharing the history and importance of Derinkuyu with visitors from around the world. These guides, often born and raised in the area, provide invaluable insights into the city's past and its cultural significance. The community has also worked closely with archaeologists and preservation experts to ensure that Derinkuyu remains accessible while protecting its delicate structures. Local craftsmen have contributed their skills to maintenance efforts, using traditional techniques to repair and reinforce parts of the underground complex. Furthermore, residents have embraced the economic opportunities presented by Derinkuyu's popularity, establishing businesses such as restaurants, hotels, and souvenir shops that cater to tourists while showcasing local culture. This symbiotic relationship between the ancient site and the modern community has fostered a sense of pride and stewardship among locals, ensuring that Derinkuyu continues to be preserved and celebrated for future generations. Derinkuyu, the ancient underground city in Turkey, continues to fascinate archaeologists and tourists alike. Current plans focus on expanding both physical and virtual access to this remarkable site. Turkish authorities are working to excavate and restore additional sections of the underground complex, potentially opening up new areas for public exploration. This careful process aims to balance preservation with increased visitor access. Simultaneously, there are efforts to enhance our understanding of Derinkuyu through advanced imaging technologies. Researchers are employing ground-penetrating radar and three-dimensional mapping techniques to create detailed digital models of the city's layout. These models will allow experts to study the site's architecture and engineering without risking damage to the fragile structures. Educational initiatives are also underway to improve public understanding of Derinkuyu's historical significance. Museums in Turkey and around the world are developing exhibits that showcase the underground city's unique features and its role in ancient Cappadocian culture. Virtual reality experiences are being created to offer immersive tours of Derinkuyu, allowing people who cannot visit in person to explore its winding tunnels and chambers. As excavations continue, archaeologists hope to uncover more artifacts and structural elements that could shed light on the daily lives of Derinkuyu's inhabitants. This ongoing research may reveal new insights into the city's construction methods, defensive strategies, and the reasons for its eventual abandonment. By expanding both physical access and our knowledge base, future plans for Derinkuyu aim to preserve this extraordinary site while making it more accessible and understandable to people worldwide. Derinkuyu's designation as a UNESCO World Heritage Site has significantly impacted its management and preservation efforts. This ancient underground city in Cappadocia, Turkey, now receives heightened attention and protection due to its global recognition. The UNESCO status has led to increased funding for conservation projects, allowing experts to implement more advanced preservation techniques. These efforts focus on stabilizing the intricate network of tunnels and rooms, protecting delicate rock-cut structures from erosion and damage caused by visitors. Tourism management has also evolved since the UNESCO listing. Authorities have implemented stricter visitor controls, limiting daily entries to prevent overcrowding and reduce wear on the site. Guided tours are now mandatory, ensuring visitors receive accurate information while minimizing potential damage to the fragile underground environment. Furthermore, the World Heritage status has fostered international collaboration, bringing together experts from various fields to study and preserve Derinkuyu. This global interest has not only enhanced our understanding of the site, but also contributed to the development of best practices for managing similar underground heritage sites worldwide. Break time. 3.7s. Archaeologists and researchers have employed a range of advanced technologies to explore and understand the ancient underground city of Derinkuyu in Turkey. Ground-penetrating radar has been crucial in mapping the extensive network of tunnels and chambers without disturbing the site. This non-invasive technique allows scientists to create detailed three-dimensional models of the subterranean structures. Laser scanning technology has also been utilized to capture precise measurements and create accurate digital reconstructions of Derinkuyu. These scans provide valuable data on the construction methods and architectural features of the underground complex. Additionally, archaeologists have used remote sensing techniques, including satellite imagery and aerial photography, to identify potential new areas of interest and to understand how Derinkuyu relates to other nearby underground settlements. Geochemical analysis of rock and soil samples from Derinkuyu has provided insights into the geological composition of the area and the materials used in construction. This information helps researchers understand the engineering challenges faced by the ancient builders and how they overcame them. Furthermore, advanced dating methods, such as optically stimulated luminescence, have been applied to determine the age of various sections of the underground city more accurately. These modern scientific techniques have greatly enhanced our understanding of Derinkuyu, revealing its complex layout, sophisticated ventilation systems, and the ingenuity of its ancient inhabitants. As technology continues to advance, researchers hope to uncover even more secrets hidden within this remarkable underground city. Carbon dating has played a crucial role in unraveling the mysteries of Derinkuyu, the ancient underground city in Turkey. This scientific technique has allowed archaeologists to determine more accurate timelines for the construction and occupation of this remarkable subterranean settlement. By analyzing organic materials found within Derinkuyu, such as wooden beams and other artifacts, scientists have been able to establish that the earliest levels of the underground city date back to around 800 BCE. This places the initial construction of Derinkuyu in the Iron Age, much earlier than previously thought. Carbon dating has also revealed that Derinkuyu was continuously inhabited and expanded over several centuries. The technique has helped identify different phases of construction and renovation, showing how the underground city evolved to accommodate changing needs and growing populations. This information has given researchers valuable insights into the long-term usage and development of this unique urban environment. Furthermore, carbon dating has assisted in correlating Derinkuyu's history with known historical events and cultural changes in the region. By providing a more precise chronology, it has allowed archaeologists to better understand how the underground city related to various civilizations and empires that dominated Cappadocia over time, from the Phrygians to the Byzantine Empire. Geological studies of Derinkuyu have focused on the unique volcanic rock formations that made its construction possible. The underground city was carved into a thick layer of soft volcanic rock called tuff, which was created by ancient volcanic eruptions in the Cappadocia region of Turkey. This tuff is composed of compressed volcanic ash and is relatively easy to excavate, yet sturdy enough to support large underground structures. Researchers have analyzed the composition and structure of the tuff to understand its properties and how it has withstood centuries of use. They have found that the rock is porous, allowing for natural ventilation throughout the underground complex. This porosity also helps regulate temperature and humidity, making the underground city habitable. Geologists have also studied the surrounding landscape to understand the broader geological context of Derinkuyu. They have examined nearby volcanic cones and lava flows to reconstruct the volcanic history of the region. This work has helped scientists determine when the tuff layer was deposited and how it has been affected by subsequent geological processes. Additionally, geotechnical surveys have been conducted to assess the stability of the underground structures and identify any potential risks. These studies have helped inform conservation efforts and ensure the continued preservation of this remarkable archaeological site. Archaeologists have employed ground-penetrating radar to uncover the hidden depths of Derinkuyu, an ancient underground city in Turkey. This non-invasive technology allows researchers to map subterranean structures without disturbing the site. By sending radar pulses into the earth and analyzing the reflected signals, scientists can create detailed images of buried features. In Derinkuyu, ground-penetrating radar has revealed an intricate network of tunnels, chambers, and passageways extending far below the surface. This technology has helped archaeologists identify previously unknown areas of the underground city, including potential living quarters, storage rooms, and ventilation shafts. The radar data has also provided insights into the construction techniques used by the ancient builders, showing how they carved out the soft volcanic rock to create this vast subterranean complex. One of the most significant discoveries made possible by ground-penetrating radar is the true scale of Derinkuyu. Initial estimates suggested the city descended about 55 meters, but radar surveys have indicated it might extend even deeper. This technology has also helped researchers understand how the different levels of the city were connected and how the inhabitants managed resources like water and air circulation. Ground-penetrating radar has proven invaluable in planning future excavations and conservation efforts at Derinkuyu. By identifying areas of structural weakness or potential collapse, archaeologists can prioritize their work and ensure the safety of both researchers and the site itself. This technology continues to play a crucial role in uncovering the secrets of this remarkable underground city, providing new insights into the lives of its ancient inhabitants. Derinkuyu, the ancient underground city in Turkey, has revealed remarkable insights into the ingenuity of our ancestors. Recent studies have uncovered sophisticated ventilation systems that allowed fresh air to circulate through the subterranean network, even at depths of 200 meters. These systems were far more advanced than previously thought, utilizing principles of thermodynamics to create natural airflow. Archaeologists have also discovered evidence of a complex water management system within Derinkuyu. This system included wells, water storage areas, and drainage channels that prevented flooding and ensured a stable water supply for the city's inhabitants. The precision of these hydraulic features suggests a level of engineering knowledge that was unexpected for the time period. Another intriguing finding is the presence of movable stone doors throughout the underground complex. These massive circular stones could be rolled into place to seal off sections of the city, providing defense against invaders. The mechanisms for these doors show a sophisticated understanding of leverage and balance, allowing a single person to move stones weighing up to 500 kilograms. The layout of Derinkuyu has also provided new insights into ancient urban planning. The city was designed with multiple levels, each serving specific functions such as living quarters, storage areas, and communal spaces. This efficient use of underground space demonstrates a level of architectural planning that rivals modern urban design principles. The underground city of Derinkuyu in Turkey has provided archaeologists with a treasure trove of information about ancient cultures. This vast subterranean complex, carved into soft volcanic rock, spans several levels and could have housed thousands of people. Artifacts discovered in Derinkuyu have shed light on the daily lives and technological capabilities of its inhabitants. Stone tools and pottery fragments indicate a sophisticated level of craftsmanship and suggest that the city was occupied for extended periods. The presence of storage areas and kitchens reveals that the inhabitants were well prepared for long stays underground, possibly to escape hostile invaders or harsh weather conditions. One of the most intriguing findings is the advanced ventilation system. Thousands of ventilation shafts demonstrate a remarkable understanding of engineering and air circulation, crucial for sustaining life underground. This suggests that the ancient builders possessed knowledge of physics and architecture that was far ahead of their time. Religious artifacts found in Derinkuyu point to a complex spiritual life. Christian symbols carved into walls and the presence of chapels indicate that the city served as a refuge for early Christians fleeing persecution. This has expanded our understanding of the spread and practice of early Christianity in Anatolia. Archaeologists and climate scientists have conducted several studies to unravel the environmental conditions of ancient Derinkuyu, the remarkable underground city in Cappadocia, Turkey. These investigations have primarily focused on analyzing soil samples, examining preserved organic materials, and studying geological formations in and around the subterranean complex. One key area of research has been the examination of pollen grains trapped in the layers of sediment within the underground chambers. This palynological analysis has provided valuable insights into the plant life that existed in the region during different periods of Derinkuyu's occupation. The findings suggest that the area experienced a relatively mild climate, with sufficient rainfall to support agriculture during much of its inhabited history. Isotope analysis of preserved plant and animal remains found in the underground city has also shed light on past climate conditions. By examining the ratios of different isotopes in these materials, Scientists have been able to reconstruct temperature and precipitation patterns over time. These studies indicate that the region likely experienced periods of both increased aridity and higher rainfall throughout its history. Geological surveys of the surrounding landscape have revealed evidence of past volcanic activity and its impact on local climate. The porous volcanic rock that allowed for the creation of Derinkuyu also played a role in water retention and distribution, influencing the agricultural potential of the area. This interplay between geology and climate has been crucial in understanding how the inhabitants of Derinkuyu adapted to their environment over centuries. The discovery and study of Derinkuyu, an ancient underground city in Turkey, has significantly expanded our knowledge of ancient urban planning and engineering. This remarkable subterranean complex, carved into soft volcanic rock, dates back to around the 7th or 8th century BCE and extends to depths of approximately 200 meters. Derinkuyu has revealed sophisticated design principles that ancient civilizations employed to create sustainable living spaces in challenging environments. The city features an intricate network of tunnels, rooms, and ventilation shafts, demonstrating advanced knowledge of air circulation and temperature regulation. This understanding of environmental control in underground spaces has shed light on how ancient societies adapted to harsh climates and security threats. The layout of Derinkuyu also provides insights into the social organization of its inhabitants. The city includes distinct areas for living quarters, food storage, religious practices, and communal activities, indicating a well-planned societal structure. The presence of security measures, such as rolling stone doors and narrow passageways, suggests a need for defense against external threats, offering clues about the geopolitical climate of the time. Furthermore, the study of Derinkuyu has prompted archaeologists and urban planners to reconsider the potential of underground spaces in modern city design. It serves as an example of how vertical space can be efficiently utilized, a concept increasingly relevant in today's densely populated urban areas. The ancient city's innovative water management systems and long-term food storage solutions also provide valuable lessons for sustainable urban development in the present day. Archaeologists have made fascinating discoveries about ancient metallurgy by examining tools unearthed in the underground city of Derinkuyu, located in modern-day Turkey. These findings have shed light on the advanced metalworking techniques employed by the inhabitants of this subterranean settlement thousands of years ago. The tools found in Derinkuyu reveal that its ancient residents possessed sophisticated knowledge of copper and iron working. Analysis of these implements shows evidence of complex forging techniques, including the ability to create alloys with precise compositions. This level of skill suggests that the metalworkers of Derinkuyu had a deep understanding of the properties of different metals and how to manipulate them effectively. One particularly intriguing discovery is the presence of tools made from meteoric iron. This rare material, prized for its strength and durability, indicates that the inhabitants of Derinkuyu were not only skilled metalworkers, but also astute observers of their environment, capable of recognizing and utilizing extraterrestrial resources that fell to Earth. The study of these ancient tools has also provided insights into the daily lives and economic activities of the people who lived in Derinkuyu. The variety and quality of metalwork found suggest a thriving craft industry, with specialized artisans producing tools, weapons, and decorative items for both local use and trade with other communities. Genetic research on human remains from Derinkuyu has provided fascinating insights into the ancient inhabitants of this underground city in Turkey. DNA analysis of bones and teeth found in the subterranean chambers has revealed a diverse population with genetic links to both Near Eastern and European ancestries. This suggests that Derinkuyu was a melting pot of different cultures and ethnic groups, likely due to its strategic location along ancient trade routes. The genetic data also indicates that the inhabitants of Derinkuyu had a high level of genetic diversity, implying a large and well-connected population. This supports archaeological evidence that the underground city could accommodate thousands of people. Interestingly, some genetic markers found in the Derinkuyu samples are still present in modern Turkish populations, suggesting a degree of continuity in the region's genetic makeup over time. Furthermore, analysis of mitochondrial DNA, which is passed down through maternal lines, has shed light on the migration patterns of women in ancient Anatolia. The results indicate that there was significant female mobility, with genetic signatures from various surrounding regions. This challenges previous assumptions about the static nature of ancient societies and highlights the complex social dynamics at play in Derinkuyu. These genetic findings complement archaeological and historical evidence, painting a more complete picture of life in this ancient underground city. They reveal a cosmopolitan society that was well connected to the wider world despite its subterranean nature, and provide valuable information about the population's health, diet, and social structure. Break time. 3.7s. Derinkuyu, the ancient underground city in Turkey, has sparked numerous local legends about its origins. One popular tale suggests that the vast subterranean network was created by giants, explaining the enormous scale and complexity of the structure. According to this legend, a race of powerful beings carved out the city as a refuge from some long-forgotten calamity. Another widespread story attributes the construction of Derinkuyu to a group of persecuted early Christians. This legend claims that the followers of Jesus sought shelter from Roman oppression by building an elaborate hidden city beneath the earth. The narrative emphasizes the ingenuity and determination of these early believers in the face of adversity. Some local accounts even link Derinkuyu to extraterrestrial visitors. These stories propose that advanced beings from other worlds created the underground complex as a base of operations or a refuge during their time on Earth. While lacking scientific basis, this legend reflects the awe inspired by the city's sophisticated design and construction. Regardless of their veracity, these legends highlight the enduring mystery and fascination surrounding Derinkuyu. They demonstrate how extraordinary human achievements can give rise to imaginative explanations when the true origins are lost to time. The actual history of Derinkuyu, while less fantastical, is no less impressive, showcasing the remarkable capabilities of ancient civilizations. Derinkuyu, the ancient underground city in Cappadocia, Turkey, has become deeply woven into the tapestry of regional folklore. Local legends often portray Derinkuyu as a place of mystery and protection, with stories passed down through generations about its origins and purpose. Many tales describe Derinkuyu as a refuge created by ancient people to escape from invaders or harsh weather conditions. Some folklore attributes the construction of the underground city to supernatural beings or giants, explaining the impressive scale and complexity of the subterranean network. In more recent times, Derinkuyu has inspired modern myths and urban legends. Some locals believe that undiscovered passages still exist, leading to hidden chambers or even connecting to other underground cities in the region. These stories often include accounts of people hearing strange noises or feeling unexplained drafts of air, hinting at the presence of undiscovered sections. The mysterious nature of Derinkuyu has also led to its incorporation into religious and spiritual beliefs. Some folklore suggests that the underground city served as a sanctuary for early Christians, while others claim it was a sacred site long before the arrival of organized religions. This blend of history and myth continues to captivate both locals and visitors, making Derinkuyu an enduring part of the cultural landscape. Derinkuyu, the ancient underground city in Turkey, has sparked numerous local legends and stories over the centuries. While not exactly mythical creatures in the traditional sense, tales of mysterious subterranean dwellers have circulated among the local population. Some stories speak of shadowy figures that still inhabit the deepest, unexplored parts of the underground network. One persistent legend tells of the Yer Alti İnsanları, or the underground people. According to local lore, these beings are neither fully human nor spirit, but something in between. They are said to be guardians of ancient knowledge and protectors of the underground city. Witnesses claim to have caught glimpses of these elusive figures in the dimly lit corridors of Derinkuyu. Another tale mentions the Karanlık Gezginler, or dark wanderers. These are described as ethereal entities that move silently through the underground passageways. Local stories suggest they are the spirits of the original inhabitants of Derinkuyu, forever bound to their subterranean home. Some believe these spirits help lost explorers find their way back to the surface. While these stories are not based on scientific evidence, they reflect the profound impact Derinkuyu has had on the collective imagination of the region. The mysterious nature of the underground city, with its labyrinthine passages and hidden chambers, continues to fuel these fascinating local legends. While Derinkuyu's construction has fascinated researchers and the public alike, it is important to note that there are no credible supernatural explanations for its creation. The underground city in Turkey was built by human hands using tools and techniques available at the time. Some fringe theories have suggested extraterrestrial involvement or ancient advanced civilizations, but these claims lack any scientific basis. Instead, archaeologists and historians attribute the construction of Derinkuyu to the Phrygians in the 7th or 8th century BCE. The city was later expanded by early Christians seeking refuge from Roman persecution and Arab invasions. The complex network of tunnels, rooms, and ventilation shafts was carved out of the soft volcanic rock over many generations. The impressive engineering and architectural skills displayed in Derinkuyu often lead people to seek extraordinary explanations. However, the city stands as a testament to human ingenuity, perseverance, and the ability to adapt to challenging environments. The ancient builders used simple but effective methods to create a sustainable underground living space, complete with water systems, storage areas, and defensive mechanisms. While not supernatural, the true story of Derinkuyu's construction and use throughout history is no less fascinating. It provides valuable insights into ancient urban planning, engineering capabilities, and the lengths to which communities would go to protect themselves in times of conflict. Oral traditions have played a crucial role in preserving and transmitting knowledge about Derinkuyu's history. These ancient underground cities in Cappadocia, Turkey, have long been shrouded in mystery, and local legends passed down through generations have provided valuable insights into their past. Many stories told by local residents describe Derinkuyu as a refuge for early Christians fleeing persecution. These oral accounts have helped archaeologists and historians piece together the potential purposes and timelines of the underground network. The tales often mention secret passages, hidden entrances, and elaborate defense mechanisms, which have been corroborated by subsequent archaeological discoveries. Furthermore, oral traditions have shed light on the daily lives of Derinkuyu's inhabitants. Stories passed down through families describe how people lived, worked, and worshipped in these subterranean chambers. These accounts have provided researchers with valuable clues about the social structure, religious practices, and survival strategies of the ancient occupants. While oral traditions alone cannot provide a complete historical record, they have served as important starting points for further investigation. By combining these ancestral stories with archaeological evidence and historical documents, researchers have been able to construct a more comprehensive understanding of Derinkuyu's fascinating past. Derinkuyu, the ancient underground city in Cappadocia, Turkey, holds immense significance in shaping the cultural identity of the local population. This remarkable subterranean complex, carved deep into the soft volcanic rock, stands as a testament to the ingenuity and resilience of the people who once called it home. For the modern inhabitants of Cappadocia, Derinkuyu serves as a tangible link to their ancestors and a source of pride in their heritage. The intricate network of tunnels, rooms, and passageways spanning multiple levels underground showcases the architectural and engineering prowess of their forebears. This connection to the past fosters a sense of continuity and belonging among the local population. Derinkuyu also plays a crucial role in the economic and social fabric of the region. As a major tourist attraction, it brings visitors from around the world, contributing to the local economy and providing employment opportunities. This influx of tourists has led to a renewed interest in preserving and sharing the history and culture of the area, encouraging locals to become stewards of their unique heritage. Moreover, the underground city serves as a powerful symbol of survival and adaptability. The ancient inhabitants of Derinkuyu created this hidden sanctuary to protect themselves from invaders and harsh environmental conditions. This legacy of resourcefulness and determination continues to inspire the local population, reinforcing their identity as a community capable of overcoming challenges and thriving in difficult circumstances. Derinkuyu, the ancient underground city in Turkey, has connections to several religious and spiritual beliefs. Early Christians used these subterranean chambers as refuge during times of persecution, leaving behind chapels and religious artifacts. Some scholars believe the city may have origins in Hittite culture, potentially linking it to their polytheistic beliefs. Local legends also associate Derinkuyu with the mythical land of Cappadocia mentioned in the biblical Book of Acts. This connection has made it a site of interest for religious pilgrims and researchers studying early Christianity. The complex network of tunnels and rooms has sparked theories about its use for mystical or esoteric practices, though these remain speculative. Interestingly, some modern spiritual groups have found inspiration in Derinkuyu, seeing it as a symbol of human ingenuity and adaptability in the face of adversity. The city has become a focal point for discussions about ancient wisdom and the potential for underground living in contemporary times. Ancient legends about Derinkuyu, the underground city in Turkey, have captured imaginations for centuries. Modern interpretations of these tales have evolved significantly as archaeological discoveries shed new light on this remarkable subterranean complex. Originally, local folklore attributed the creation of Derinkuyu to supernatural beings or giants. Some stories even suggested it was built by extraterrestrial visitors. However, contemporary research has revealed a more grounded yet equally fascinating history. Archaeologists now believe the city was constructed by the Phrygians in the 7th or 8th century BCE and later expanded by early Christians seeking refuge from Roman persecution. Recent studies have also dispelled myths about the city's size and capabilities. While early legends claimed Derinkuyu could house tens of thousands of people for extended periods, modern estimates suggest a more modest capacity of around 3,000 inhabitants. This realization has not diminished the city's importance, but rather highlighted the ingenuity of its builders in creating a sustainable underground refuge. The evolution of these interpretations reflects a broader shift in how we approach ancient mysteries. Rather than relying on fantastical explanations, modern scholars seek to understand the human motivations and engineering prowess behind such remarkable achievements. This scientific approach has transformed Derinkuyu from a subject of myth into a testament to human resilience and adaptability in the face of adversity. The legends surrounding Derinkuyu have significantly shaped public fascination with this ancient underground city. Many people are captivated by the idea of a vast subterranean network that could shelter thousands of inhabitants, sparking imaginations about the ingenuity and resourcefulness of our ancestors. These stories have led to increased tourism in the region, with visitors eager to explore the mysterious tunnels and chambers for themselves. The popular perception of Derinkuyu often includes elements of intrigue and secrecy, with some speculating about hidden treasures or lost knowledge within its depths. This has sometimes overshadowed the historical reality, leading to misconceptions about the true purpose and daily life in the underground city. While archaeologists understand Derinkuyu as a sophisticated refuge from external threats, many in the general public view it through a lens of adventure and mystery. These legends have also influenced how Derinkuyu is portrayed in media and popular culture. Documentaries, books, and even video games have drawn inspiration from the underground city, often embellishing its features or history for dramatic effect. This has further cemented Derinkuyu's place in the public imagination as a symbol of ancient engineering prowess and human adaptability. Archaeologists studying Derinkuyu, the ancient underground city in Turkey, face the intriguing challenge of balancing local folklore with hard, scientific evidence. This process involves careful analysis of both oral traditions and physical artifacts to piece together a comprehensive understanding of the site's history and purpose. The folklore surrounding Derinkuyu often speaks of giants or otherworldly beings creating the vast subterranean network. While these tales may seem fantastical, archaeologists recognize their potential value in preserving cultural memory and pointing towards historical events or environmental factors that influenced the city's construction. They examine these stories for kernels of truth that might align with or illuminate archaeological findings. Scientific evidence, on the other hand, provides tangible proof of human activity and engineering prowess. Archaeologists use techniques such as carbon dating, stratigraphic analysis, and material composition studies to determine the age and purpose of various structures within Derinkuyu. They also employ advanced imaging technologies to map the extensive network of tunnels and rooms, revealing the ingenuity of its ancient builders. By combining folklore and scientific evidence, archaeologists create a richer, more nuanced understanding of Derinkuyu. This approach allows them to respect local cultural heritage while uncovering the factual history of this remarkable underground city, providing insights into the lives, beliefs, and technological capabilities of its inhabitants throughout different periods of occupation.